the right way to go. Ultimately, the typing field just wasn't there, and the silicon buttons looked a little big. So I decided on a sort of double shot with using plastic keys, similar to a plus-size keyboard, with inlaid button lettering buttons. Started with resin plastic key. I arranged the keys in just a 10 and ordered some details. The quality of the tested all flush cutter. I can move up to the next step inlaying. The legends they used a white air-dry clay to contrast the black keys. I pressed the clay into the embossed letters. The clay was dry and I could add a top coat to make sure the clay knobs were smooth, as you see here, and the legends will fall out. The top coat is just made of whatever clear nail polish my had. So the quality on it is really fantastic, but it does the job pretty well for Windows. And of course all these individual keys that come into the case as well. You can see that the components on the screen PCB have actually been flipped to the other side of the circuit board. This means that they're visible from the outside case or the clear plastic. In the process of moving these over, I actually neglected to mirror this connector here to connect whatever connection needs to be on the right side is actually on the left side, and they just go in the wrong order. So unfortunately, I did have to coil this ribbon cable up a little bit weird to get it to fit in here and work properly and not fry the top PCB. But you can see that the connectors for this are actually in line. So in the next version, I'll have that fixed, and this ribbon cable will come out straight and actually connect properly between the two. You can also see that I've added a guard. This is plastic. That's to keep the ribbon cable protected when it's open and closed, and it kind of goes over there to protect it. Okay, and now for the new software updates. So in this version, I have changed quite a bit in terms of software. I guess starting on the home screen here, the first major change is, as I mentioned before, we have a nice time and date readout here, but also there's a new way to interact with the home menu. So instead before you had to press 1, 2, 3, 4, 5, etc. To choose an app, and that still works. You can still type 1 and get to the text app if you want. But the main way that you interact with this is that you actually just type what you want to do. So if I want to go to text, I type text. If I want to go to File Wizard, I can do Wiz, or I can do File Wiz, whatever I want to do. So this, I think, allows for a lot of commands that, you know, you can ask it, what can you do? And obviously that's a pre-programmed response there. But there are a lot of commands that make this easier to use through this. So I found, I was inspired by AutoCAD where you type in like say circle, maybe the circle tool. This is a similar way. I also had, just for an example, time set, and then if you type like 39, you hit enter, this will change to 12:39. So that's a way that you can enter the time. But anyway, we use this first to launch the text app. And you'll see some new changes here. So the major change with this, obviously I mentioned it's been rewritten. This new text app has a completely new operation, because as you're typing here, see that if you hit space, it doesn't send the word directly here. And I did that because I realized it kind of sucks a little bit not to be able to edit whatever line you're on, because if you make a typo while you're typing quickly, and then it gets sent to the screen, then you're kind of out of luck because you can't go back to edit. And this may be something that I can fix in the future by allowing you to go back and edit, but for now I think this is actually a better way to do it. And we can see here that there is actually a bar at the top as well, type stuff, this bar gets longer and longer across the screen until eventually it gets to the end. And there is an indicator here that tells you when you're getting about 20% of the end, so you can make sure to finish your thought on it if you want to do it that way. But once you get to the end, you can see that we automatically get our line sent from the OLED to the e-ink. So I think this is a better way to do it, and this progress bar here is actually based with characters that are being put up here. So this works with any font, is basically what I'm saying. No matter what font you use, this progress bar is always going to fill up correctly and give you the lines correctly. So that is the major change that I made on this version that I think is going to make this a little bit more usable. So if we go ahead and load up that example text that I was showing earlier, we can see we have a text full of information. There's a list on the bottom. There's paragraphs. I added tabs for indenting. And I guess this is a good text to exemplify the scrolling mechanics. So this here is a capacitive touch strip. It's controlled by a capacitive touch IC here. And there are traces that go to each of these pads. And I can sense them individually. And when you move up and down, if I zoom in a little bit here, you can see that there's a preview on the bottom of what text you're looking at. So you can see the tabs represented there, and you can see the line lengths, which kind of help you visualize where you are scrolling in the text. So if I go up here, you can see that once I released it, it'll send you to that part of the text. And if I scroll down, we get back down to that bottom part. So obviously e-ink updates very slowly, so there wasn't a great solution for scrolling. Obviously if you can update live, that would be the best thing, you know, like a cell phone does. But the next best thing is, I think, a preview of the text represented in lines, just the length of them, so that you can see kind of where you are relative to other things in the text. And then once you're done scrolling, it flashes out there on the screen, giving you the information. So let's try something else out. You can clear this. And I'm going to open up a new file. We're going to name this file test. Okay, so we're just going to type something really simple. Let's type that line. Now you can see that we have this simple line in our chosen font. If we want to change the font, we can hit F-N on the tab, and up top is the font list. So this allows you to change the current font that's used by the text editor program. So say we wanted, what we have now is kind of like a thinner and small font. This is good for having a lot of information on the screen. It can fit a lot more characters than the other ones. But say you wanted a more bold font, you can choose number 1, and you can see that the line gets, or the text gets updated with the new font, and the line, since these characters are a lot bigger, actually went on to the next line. And if we switch it again to an even bigger font, a giant one like number 6, we can see that even though this word cannot fit on this line, it's going over. So yeah, let's get into the next tab. To go along with this new time that I added here, I thought it would be cool if there was kind of a desk mode. You set this thing on your desk and it acts as a little analog clock, and it tells you your upcoming tasks, like a sticky note that's sitting on your desk. So if I grab USB-C cable here, this guy in, we can see that we get an update here with the battery charging indicator. This battery indicator actually works. It did not work before. And then we have sleep on the side. This is an actual false back up, it just goes back into another boot, and I can show you the tasks where I added those, homework I said. So if I enter task here, you may also notice that this has been flashing a lot more. I realized I actually burned through one of my first meeting displays. On the last revision, I burned through it because I partial updated it too much. These displays are actually a lot more fragile than I initially realized, and you need to make sure in the code that you're using them within their operating conditions. You need to, every 5 refreshes or so, 5 partial refreshes or so, you need to do a full refresh to make sure that the pixels are cleared out and not fade or anything. But anyway, task tab. So this is a simple little widget, I guess, to add a name and a date. That's all you get. A name and a date. Very simple. What is the name of the task and when is it due? And it does sort them in order of when they're due as well. But if I want to add a new task, I can hit add new. And it's going to prompt me to enter a task name. So let's say edit. And it's going to ask me for a due date. I guess I don't really have a due date for this one, but I'll just put it on 25 March 30th. It's going to save it, new task added, and it's going to add that. So you edit video due on March 30th, 2025. We can also here, if I decide that I didn't get my video out in time and I haven't earned ice cream, I can choose number 4. I can choose to delete the task. So, and these tasks do update on our nice now and later as well. I saw here, you can see now we got walk the dog. So you can sit this on your desk and have a nice little clock, have a to-do list, and power on when you need it. That's nice. And I actually forgot to mention this earlier, but if we hop into the text tab here, and then we hit the sleep button, we'll see that actually this was recommended to me. Instead of flashing the screen with an image, we left the content on the screen on there. We'll just put a little sleeping icon in the corner. So this allows you to have the device off. This is completely turned off. It is using almost no energy. But you can still see the content on the screen. You can still see what I'm doing. And the last new change was File Wizard. So if I do File Wizard here, little file app. Let's say test.txt, for example, like this, and we have a nice little file wizard here. It is willing to perform these spells for you, namely Renamio, Deletius, Capinio, and Elabora. Yeah, I know, very stupid name, but just go along with it, okay? Renamio obviously renames, delete a file, copy a file, show more information about the file. So let's rename this test.txt. It's going to prompt me to enter a new file name. There's some rows, no spaces, stuff like that. So it was test before, so let's go crazy. We'll call it test 2. I know, it's same. Okay, so we renamed our file, and we can set back to this screen, and we can see that that file is now test 2. Say we hate test 2. We want to completely get rid of it. Let's do that. Here, hit delete. It'll make sure that you want to delete your file. You're going to hit Y to delete it. And to not delete it, say Y. It's going to say deleted. It's going to be back, and that file's gone. So this works pretty well. There's even a copy function. So if I hit this, and I hit copy, it's going to ask me for essentially a name for the copy. So let's call it 2. There we go. So now we got 4 episodes. So if we go stuff in there, what date it is, what time it's at, and be able to keep, track of your things that you need to do on a calendar instead of just a list. I also want to add a journal app, and I'll put a picture of what I'm thinking right here. I've already started to work on that. It's going to have kind of it's going to be like a daily journal kind of thing, where it has sort of a GitHub inspired, activity chart. Every day that you do your journal, it's going to fill in a little square, and so you're going to be able to see your progress very clearly, and it's going to motivate you to journal daily, essentially, because I think that's it. I also want to add an SD card slot. This thing currently only has 8 megabytes of memory, and that's handled internally on the ESP32, because that'll allow you to put a lot more on this, and I'm not exactly super confident in the memory that's on here. I don't know how robust it is, or if it will last a long time, but I think an SD card is good. I also am working on a way to transfer files from the device onto, say, a desktop or a laptop, or even maybe a tablet or a cell phone or USB or Wi-Fi. So lots of options there. We'll see what I figure out and what works the best. I was also playing with the idea of having notes that can sync to Google Drive, which I think would be really cool. If you're on Wi-Fi, you can sync your files to Drive, have them saved automatically and updated, and that way you can edit files here on the go, and when you get home, they'll be synced to your Google Drive, and you can edit them on your computer, refine them, and stuff like that. Also, for people who like to write on the go and don't like this little keyboard, obviously this is good for quick notes, but not, longer writing. I'm gonna plan to add Bluetooth keyboard support, so you can pair a Bluetooth keyboard up to this guy, set it up on the desk, and type away on your Bluetooth keyboard using this. And that'll hopefully make the experience a lot easier if you're wanting to, write something a little longer on this. In my last video, I got a lot of comments and emails of people being like, please make me one, can I pay you to make me one? And the response was very similar to all of those. I don't feel comfortable making this for you yet, because it's not a complete product, and I want to make sure that if I'm making this or selling this to people, that it is a complete product and not, going to fall apart. The software is going to be up to snuff and not buggy, so it's not ready yet for that, unfortunately. So here's my plan. We all hate incomplete products, EA. I think the hardware needs at least 1 to 2 more revisions before I'm happy with it as a product or as a kit. And after this, I'll likely begin selling a development kit of this, where it includes, the PCBs, everything you need to build one, and people can buy the kit and build it themselves. At that point, I'll also be open sourcing all of the design files for this, the PCB Gerber files, the 3D files for all these buttons, the bill of materials, what you need to buy to actually make one of these. And that'll all be open source, so if you don't want to buy the kit online, you can purchase all these parts yourself and put it together completely of your own vision. But for those who don't want to do that, and also because of the way scaling works with production, it'll probably be cheaper to buy my kit, but you can just download it for free and, do it completely yourself. That's fine too. At this stage, the device is going to be in a sort of alpha testing, and you're going to be part of the development, which is really cool, but it's not going to work completely well. It'll still be in testing and in production. And this is where you guys step in. So by trade, I'm a mechanical engineer, and if you have taken a look at my GitHub, you can probably tell by the way I code. So I'm hoping that some community members can, help to build upon what I've created and make it better, as well as work with me to add features to the device to make it more usable. Once I consider the product complete, I'll probably sell these as a complete kit, once I'm comfortable with this as a product. And I guess maybe for a higher cost, I'll assemble it for you. These are handmade, so it'll probably be a much higher cost, but for people who don't have access to the tools or don't have the skill set but still want to participate in this project, then I will probably likely offer that option. This all being said, if you are very interested in the product and you want to follow the development, There are some YouTube buttons down there. You know about them already. If you're really interested, I've created a Discord server where I'll be posting periodic project updates and getting community feedback, and that link is also in the description. As always, thank you so much for watching and supporting the channel, and I hope you have a really good day.
This MP3 file is malware. It is literally a .mp3 file. It's a sound file, it's an audio file, it is actually a song. I'm taking a look at the details here. Apparently, Gnosis hardware from Professor Click, produced and available on Jamendo.com, which is a real thing, apparently. Jamendo.com lets you stream music. And this is a totally playable audio file. It's a song, right? Gnosis hardware from Professor Click. Play it for you, and that's that. But here's the thing. This was sent to me in an email, and thank you so much. Please do keep sending me malware. This was a click fix or CAPTCHA scam, Windows key plus bar scam, but it's an audio file. Individual says, hey, I'll be quick. Came across a WinR dialog scam, but it's an audio file. Here's the copy text, and they include the link here, defang, redacted, to not include the full schema, but it says here, it basically MSHTAs this file, being the MP3 file. So if this MP3 file were invoked with the mshta.exe file, built-in, native, always installed on Windows operating systems, well, then we'll do something entirely different. It's how you open this file with a different program. Not to say the MP3 file or the song is malware, but it contains malware and it'll execute with MSHTA. And MSHTA is the Microsoft HTML application. If I hop over to see Windows System 32, we can find it here, mshta.exe, Microsoft HTML application host. Now this, by default, will render and display HTML, hypertext markup language, the structure language of the internet in web pages. But invoked locally on a Windows computer, it'll evaluate, run, and execute other scripting languages, like VBScript or JScript, a dialect of JavaScript, but client-side on Windows. Now, we've covered this in many videos before, but MSHTA is interesting because it is one of the few programs that allows you to work with files that are polyglot files. So a file that is one type of file, like an MP3 file, but another type of file at the same time. They're both totally valid. MSHTA will skip over and ignore everything that isn't valid code that it's able to work with. So inside of this MP3 file is malicious code that we can explore. It is going to be either HTML or JScript or VBScript, right? So it's plain text. It's a scripting language that we can read and make sense of. I'll drag this into Sublime Text, my text editor of choice, but being a binary file like .mp3, we're not going to be able to make much sense out of this. It's just the hexadecimal representation of the raw bytes. But being plain text, we could carve this out with super simple but overpowered tool, strings. So let me open up a Windows terminal here, and I'll full screen this with F11 so we can see it a little bit better, and I'll hop over to that directory. I do have it in my malware directory for MP3, and I'm actually going to use the strings that's included in the sysinternal suite. I do have that downloaded inside of my Windows 11 virtual machine here. It will need to accept the EULA or that end user license agreement, but with that, we can just give it the file, and then it'll carve out all the plain text strings that it can parse. Super simple. I don't think I need to particularly explain the usage of strings to you, but because it'll dump so much stuff, it is probably worth noting what are the other arguments or parameters we can provide. I'll hit Control-C to stop that, but if I were to actually supply another argument, like -n, that'll specify the number of characters that it will use to consider, okay, this is a string. By default, I think the minimum is 4, but if we tighten that up to 8, well, okay, now you can see a longer length there and some sketchy stuff. Let's adjust that again. How about 12? Okay, now you can see all this present. It's obviously going to be a very long line. So what if we set that to 100? And then we might be able to carve out just that blob. Sorry, I know it's got a little bit of a matrix look to it, but let me redirect that and actually put it into, I guess, stage 1 dot, well, HTA, right? It's going to be hypertext or HTML with some scripts included. So let me try to open that up with our stage 1, using Sublime Text again, but this included the little banner from strings. And then the very end, okay, we do see another long one, ELDEN, probably a leftover artifact from the MP3 file. It just happened to be longer than 100 characters long. So this is the mouth. Let me save this, and if I try to set the syntax to HTML, well, because these are all on one ginormously long line, at the very bottom you might be able to see 102,719 characters selected, so that's quite a big thing over on the mini-map sidebar here. What we can do to break this up is knowing, okay, what are they using as sort of a limiter for different commands or instructions they might use. Normally we do this with semicolons, but with this being HTML and trying to include different script segments in Visual Basic Script or JScript, I believe it'll default to JScript here. You can see a lot of frequent ending script tags, right? If I highlight these with Control F, they are all over the place. So we might be able to use that ending script tag as our delimiter, where if we were to replace all of them with some new line characters, and I'll make sure regular expressions are on so that we'll parse and process properly with our new lines, I'll hit replace all, and now we've got our syntax highlighted. And this is much easier to read. But a lot of this code looks like nonsense. In fact, it doesn't even look like code. But if we get back to the very top, this is where they do something that I think is kind of neat. Hey, real quick, before we dive too deep into the code and fall down the rabbit hole, please do let me take just a couple moments to tell you about the sponsor of today's video, Vanta. Whether you're starting or scaling your company's security program, demonstrating top-notch security practices and establishing trust is more important than ever. Vanta automates compliance for SOC 2, ISO 27001, HIPAA, and more, saving you time and money, while helping you build customer trust. You can streamline security reviews by automating questionnaires and demonstrating your security posture with a customer-facing trust center, all powered by Vanta AI. Over 7,000 global companies like Atlassian, Flow Health, and Quora use Vanta to manage risk and prove security in real time. And you get a special offer of $1,000 off Vanta with my link below in the video description, jh.live/Vanta for $1,000 off. That's a discount just for our community, jh.live/Vanta for $1,000 off. Huge thanks to Vanta for sponsoring this video. But if we get back to the very top, this is where they do something that I think is pretty neat. You can see the very first script or line of code that's ran, they move the window.move to, with an X and Y position here, X being, okay, very top is 1, but 99999 means, okay, we're going to move that way off screen, so the window, default graphical user interface for an HTA file, is not actually going to be seen. It hides it from the user. And then, this is the neatest thing, window.onError is set equal to a function that will return true. Totally anonymous functions have a name, doesn't need a name, but what that means is it's setting an error handler. So if any errors happen, like if there's any bad syntax errors or any of the other lines of code that follow in other script tags, since we'll keep that global context with, browser-based scripting languages. All of this code that does not make sense, that is not real or valid code, is going to be totally skipped over because it set that error handler to completely ignore or return true, you're fine, no big deal, for any and all errors. This is pretty slick. That means that all of this code does not matter. Dare I even call it code, because clearly it's not. Hard part is, though, now we're looking for a needle in a haystack. Do we know which of these many lines, if you go to the end, okay, about 1,000 of them, what do these even matter? Window.close at the very end, okay, finishing it up, but all the stuff in between, I don't want to have to sift through 1,000 of these. Thankfully, we can use the mini-map and just sort of do some broad strokes here to be able to see, okay, does anything stick out? And you might have already seen it. Yeah, giant chunk of data there. That's probably going to be used. we're looking at the scripts all above and below that really do anything previously or after, none of them seem to matter. But this one probably does. The line is so long that we don't even have syntax highlighting for that script tag, but look, it's setting a variable, IJOOZM, to this giant block. So what we can do next is just simply look for the usage of that variable. I'll Control F for that. Okay, now line 854, when it was defined 334, 854 actually starts to do something with it, and it uses the eval statement, which means execute more code. It'll treat whatever string or data that's passed to it as syntax and more code to run. That is kind of a little detonator. That's another stage of malware that we can extract and unravel. What they do is they take that IJOOZM variable and replace with some regular expressions here, only noting not meaning match any character, but the parentheses noting to group or cluster one match or result. It'll only take the first two characters out of a set of 3, and then it ends up parsing it as an integer in base 16. Hexadecimal, right? Now we probably saw that pattern when we were looking at the variable, despite it being a giant blob of nonsense, only the first few characters match what would be hexadecimal syntax, right? 7-6, ignore the Z, 6-1, ignore the X, 7-2, ignore the F, etc., etc. So what we could do is actually grab this line and then create our own little script to evaluate it. We'll actually use the syntax and the code itself to determine what the value inside of the eval function actually is. But we'll be sure to sort of defuse this, right? We won't actually want to call eval. If I set this to JavaScript, that's just an example. Let me turn word wrap back on. Let's be sure to remove the eval function and its leftover parentheses closing there. Since this is JScript, similar enough to JavaScript, we can let this run and evaluate in 2 different ways. We can do it even in our browser. Like if I were to open up Brave, nothing wrong with that, you could use any of them. I can hit F12 to open the developer tools and then get into a console, or I could just execute any code that I wanted. JavaScript in this case, but the syntax is so similar that it won't make much of a difference. Or we could do something like running it with Node.js locally, just running JavaScript, or honestly, back in Sublime Text, we could just save this with a stage2.js extension, being JScript in this case. Back over in Windows Explorer, you can see stage2.js would run naturally with like wscript.exe or cscript.exe, running it from the command line on Windows. Just because it's kind of neat, I will actually go run this in a web browser, and if I try to paste this, it will whine and yell at you. You need to make sure that you hit allow pasting, and then with that, I can hit Control-D, enter all this, and it'll evaluate now what the second stage is actually going to end up being, while it would have been passed to eval. Let me right-click, copy all of this, and I'll bring this back into Sublime Text so we can call this removing the double quotes as a string value at the end. I guess this is what, kind of stage 3 now? Still JScript. And let me turn word wrap on. Obviously, var A is setting a big variable to a array or list of all these integers, and how will it actually execute this at the end? Well, now you can see we're using semicolons as the delimiter for syntax that might be ran and actually evaluated. Let me replace the semicolons with a bunch of semicolons and new lines. And this isn't full, obviously. We are going to end up clobbering what looks like a for loop here, while it didn't have other conditions set in between what would be the starting value for I, and then the incrementing I iterator. Well, that's all actually defined with the var syntax in the line above. They include C to be set as an empty string, and then I as our iterator value. For the for loop, it ends up adding to that C character list to make a string from the character code at each value of that A array minus 421. Okay, so each of these should end up being an ASCII character, right? Like a letter or number, a printable character. And then it executes this with wscript.shell. The run function here will end up actually executing and invoking as if it were a command typed on the command prompt. So this line is the detonator, right? That'll invoke the next stage and the next payload. But our browser, running this in Brave or Firefox or Chrome, as we're using the developer tools in the console there, it won't really know what to do with an ActiveX object, wscript.shell, because it's meant to be invoked with HTA and CScript and the local JScript rendering. That's fine. We can just make sure we won't copy and evaluate that detonator. Let's just grab this. Everything prior and above. Pop it back over to Brave, right? We can full screen this since I'm basically using this as an interpreter. Let me paste in this value. I'll hit enter. And now we've got some PowerShell syntax carved out. Copy this, make a new document. We can say this is stage 4. Removing those double quotes at the end since those were only returned as a string. Stage 4 dot CMD command that's ran, right? Maybe not .js extension since we're clearly out of that language now, but it looks like we're actually going to be invoking with PowerShell. PowerShell.exe ran as a command, tac W for the window style, set that to hidden, tac EP for the execution policy, set to unrestricted, -NOP, actually no profile. Now the function that gets defined here is going to do what it does, apparently. This is where we can start to clean this. Let me, I don't know, put this chunk in like a stage 4a.ps1, I suppose. Paste that, word wrap back on. Now again, we can do semicolons as our delimiter. So let's find and replace semicolons. Looks like this function DJOI takes in one argument, and then we'll return the split value of the argument provided, replacing any character ... with something interesting. $ampersand to represent the actual value that it's matching on within the replacement. So ... could match any character, right? So CCEA743D, again, this is hexadecimal, but there's nothing in the way. Now it's just adding the 0x prefix so that it could actually be understood as hexadecimal. They run this on that blob of data we see, JEOLV, and then down below, after that's worked with, they use HAYZDAM, set to the value where it is joining together character representations of some AES work that they're doing here to encrypt or decrypt. As we can see, the create decryptor syntax used for the hexadecimal value, probably the key, right? Decrypting AES, the advanced encryption scheme with a given key in bytes, and then decrypting that, forgive me, based off the length of that blob value. Now, where is the detonator? I'm sorry, I keep using that word, but what will invoke now the next stage or the subsequent payload as we're sort of following down the rabbit hole here? This is what, stage 5 now? It is simply the ampersand. PowerShell will let you invoke other code to run, another string syntax to be evaluated with just the ampersand proceeding, and then it actually takes a substring of the value and gets the rest of the third position onward. So let's try to grab all this and then just let it run safely, smartly, since we know we are not going to evaluate that. What will it do? I can just slap this into PowerShell, and that's a-okay. So maybe bold, maybe brave, but let's get back to the shell that we were in, and let me just paste this in. Defines the function, spits out that blob, and then when I run this, there's no output because it's just being defined in this value. If I actually see what that is, echoing it out, boom, there's the next little snippet. But you see the first 3 characters they were working with? IEX, right? IEX is the alias for invoke expression. Once again, basically the equivalent of eval in other languages to run more code. So let's grab this bit. IEX we can probably ignore, but that's why they included that for the ampersand. Back in our text editor, now let's create stage 5, stage 5.ps1, word wrap 1. Ooh. Okay, so we start process to invoke a command, in which case that's just PowerShell again. With the window style hidden, argument list being no profile, execution policy being unrestricted. Oh, and the command that's included is this. That does some interesting things because it's all noted with this single quote, but then after the single quote ends, there are functions that are ran. And because it's wrapping a string with single quotes, the other single quotes that they use kind of need to be transformed to actually make sense in our case. these single quotes are basically acting as double quotes just to define a string, but if we wanted to clean that up and make sure that it's actually understandable for us, we probably aren't even going to consider these single quotes and that substring command that's ran from PowerShell prior. Like, this would be, I guess, in essence, a stage 5A, again, PowerShell script, because this all happens first and before this latter segment here. So let's try and make some sense of this. We can clean up by semicolons once again, and then let's see what all this does. This is really neat because they set up this string, just YP, that doesn't seem to have any other purpose because they use the pipe symbol to say, okay, that value, but then the percent sign to say for each. That is an alias in PowerShell for every element in a thing, in which case YP being a string of 2 characters. This will say for each of those, SV, which is the alias, if we actually take a look in PowerShell, for set variable. That's going to define a variable. Let's rename this so that's more clear. Defining YP as a variable set to a value of, this is really cool, PowerShell create. And defining a variable multiple times while it's set to the same value basically has no effect. It's still setting that YP to the same thing each time. So there isn't super duper a need for the for each and that YP thing there. I guess that just does it twice, I think, unless I'm not getting that wrong. But now we have YP as a variable, accessed with a $sign prefix. So inside of another code block here, null is actually set, and that's a reserve value in PowerShell, right? Obviously, if I Control-C out, echoing null not being a variable, it's not going to have any value. It doesn't matter, it's kind of getting thrown in the trash can. We set that equal to YP being a whole new session of PowerShell, which is very cool, right? Pasting that in, it gives you like a sub-shell, PowerShell stream, and they use it to actually find internally, like reaching into its own internals, PowerShell object methods, looking for, in an abstract way, you can see the pipe and where symbol they use, where each element looping through, right, using where to filter, $_ for each option that it has, where the name is like **IP. Now you might have a knee-jerk reaction and think, oh, it's talking about IP addresses, right? Not quite. This is kind of neat. If I were to take a look at the YP new PowerShell methods and objects, if I just dump these all out, okay, there's not a lot. Obviously YP is not defined. Let's actually set YP to be that. Now I can look at all the things, methods that PowerShell can run and do. But we're looking for the ones that have a name, including IP inside of the name as like a substring. So let me try and grab that. I don't want to invoke it. I'm not going to include the following parentheses that it works with it, but in this case, copying that value and letting that run, it's actually looking for the functions, methods, and things that it can do to add script, in which case it's just adding more PowerShell, but not invoke expression, not an ampersand, none of the other neat little eval equivalents, but actually using add script to get it more power. Considering this, it's going to end up executing what it downloads from parent1 gander briskly only.shop with gnosis.mp3, so another MP3 file, right? But is it really an MP3 file? Coolest thing is that they define all this and then actually invoke it, so it's running that PowerShell code in its tiny little subshell, and then they dispose of it. Cleaning that up just a little bit so our curly braces make sense. They're all connected as they should be. So it downloads and executes gnosis.mp3, but after that happens, after it is executed, gnosis.mp3, probably since it's invoking it, it's likely PowerShell code. After that happens, set sort of like a comment or a mental thing here, because we don't know yet what gnosis.mp3 will do. But it ends up taking a value for our application data environment variable. Back in PowerShell, that should mean your user's hidden directory for app data roaming. Then it has a function here where it uses curl, the built-in, it's always included in Windows now in modern versions, curl.exe. However, in PowerShell, that is an alias to invoke web request, you would need to strictly use curl.exe to actually run the binary. Those are separate things. Be wary of that. Downloads a location, passed in as an argument, and then saves it to a file with that tag-o output value. Function down below defines another nested function in there that actually evaluates whether or not a path exists. If it doesn't, it uses this download function. We can probably rename that so it makes a little bit more sense. With whatever was actually passed to that, and then its location, but then cleaning up our curly braces, it finally runs this. But the function isn't going to get any arguments there, so I'm not super clear on what that does. But that all happens after code is executed from parent1 gander briskly only.shop gnosis.mp3, right? So we're missing a piece of this puzzle here. We need to go figure out what this is. Let me check. We can get back to Grave. I actually really like to open a private window with Tor, see if that can connect, so that way, oh, you got a little bit of safety, a little bit of OPSEC, you know, at least you're going over the onion router, and Brave makes that easy. I should say, back on the email, this link where it was hosting the GoSeeSong_Ada.mp3, the very start of this rabbit hole, I believe is offline. This is just the MP3 file that I had saved previously. This was sent about 2 weeks ago. But now that Tor is connected, let's go see if we can actually hit parent1 gander briskly only.shop. I think that is also offline. But lucky for us, that was available on VirusTotal, so I can paste it in here, and let me extract this. We'll put it just in this directory. Password is infected by default for typical malware samples. That is usually the standard, and that is the SHA-256 hash. Now let me rename this to what was gnosis.mp3, and let's see if this is an MP3 file or not. Take a look at the properties. Not a lot of metadata here for it other than what we might expect. Let me try and open this in Sublime Text because I am doubtful that that is in fact an MP3 file. Nope, it's not. As we expected, that is PowerShell. Let me save this as what? I guess stage 5B, since it's kind of before the latter end of what we saw for stage 5. This is all invoked before the end of it. Now we've got our syntax highlighting for PowerShell, but take a look at this file. There are about 39,232 lines of code here, and it's a lot of junk. Probably could see, doing a lot of math, doing a lot of operations, probably just to waste CPU cycles, essentially have this thing sleep in its own right, and a lot of variables that probably don't mean anything. This is where I admit I would be like, okay, I don't want to deal with that. I'm just going to slap it into a sandbox and let it run dynamically to see what it will do the rest of its payload. So if we were to go down that route, let me just try this thing in any run and see what happens. Now I'm going to upload the zip file so that we could actually extract it as we did previously. I'm going to drop this on the desktop. Password is once again infected. I rename this to gnosis.ps1. Let me invoke it. I'll hit enter on that, and PowerShell will run. I know my face might be in the way for a lot of the process chain, but I don't think we're going to get any love from this. And I'll tell you why. I'll show you why. Obviously taking time to run. Oh, spat out a lot of numbers. I don't know if you can see those here, but at the very end, after we get a lot of these integers displayed, nothing else seems to happen quite yet. Nope, but there was an error. I don't know if you got to see that just in a moment. Let me try to run it in our own PowerShell session, so that way we could see what that error actually is. We'll enter on the terminal, move it into the desktop. I'm sorry, I know bad resolution here, but let's invoke gnosis.ps1 again, and now we won't have the window disappear. It won't exit out because it's just not that script running. We're still in our own PowerShell session. But now integers, alrighty, there is our error. Can I zoom in on this? Exception calling invoke with 0 arguments. Operator cannot be applied to operands of type Win32 system info and null, which makes me wonder, does this malware actually work? Does it even do anything at the end of the day? Because the sample that we've seen, sample that I've seen even before VirusTotal, because I've lost track of it, I got up to this point and I was not sure where to go. Because it's a line 39232, right, at character 135. Going to the very end here, 39232 set word wrap on. Okay, now it's even harder to look at. Okay, but there's clearly a data dump here. Let me try and figure out what this does, but I think we need to use a lot of those variables that have been defined in the sea of nonsense that I don't know exactly what they do. You can catch a very cool little Russian comment here. Figure out what that says. Nothing fancy, just hop into Google Translate Russian for key. Okay, so likely decrypting with AES, just as we've seen prior. And then it does almost like an XOR later on. But could we even carve this out? We have a variable that's going to work using something as a type, but that's just defined as all of this that uses the other variables that are defined elsewhere repeatedly. Okay, we actually get that set to something with some of the math with other variables that are defined. So gosh, it's hard to track that down. We can use any run though, kind of to aid us and see, okay, can we figure out what those values actually are? The ones that are used in this. And let me say this is uncharted territory, so I might have to jump around and skip a lot for video playback, just for me to figure out what even works. Let me try to extract all of the different variables that are used, define them all, and then use these. I will hit the unique values of this, and then we probably don't need the iterators. But now, what will any run tell us is actually happening with these values? Pretty sure I could echo this. Actually, this is equal to that. And if I don't include that, that should be able to display it right just fine, right? For context, all I used was Control-Shift-L to be able to create multiple cursors and sublime text. Is this gonna run? What's going on? Paste. Do it. Okay. Oh, it's all running from that same content. Dang it. We need to like dot source it. All right, I just restarted the session. Let me run it again, but I want to make sure to dot slash it. That way all the variables will stay in scope for our PowerShell sessions. Okay, there's our invoke error, and it's on an equals of something. But if I were to paste in all the stuff that we had previously, can I now paste this and see those values? Okay, cool. It's getting some stuff. And all of the things that have negative, all the bytes kind of make it hard to read. Okay, but it is going to create a script block with more stuff. So I think I should echo something into like test.text, and at the very end of each of these, add them to test.text, right? That way we can carve out all the contents and see it for real. It'll be a little bit easier to read anyway. Let's try and send that. All right, I'm trying it again, but this time I'm using PowerShell command list to like add content rather than using the greater than, like waka waka append syntax. All right, so the file is too big to extract through any run, so I'm going to see if I can upload the test.text, like all the variable values, out to a public site and then pull it down to the virtual machine. Okay, we get our integers and the error, and then if I pasted everything to log the variable values in test.text, now I want to upload these, and I'll use events. Drag and drop your files. Okay, yeah, drag and drop with it. Look at this. Upload. Please. 879QM. A79QM. Oh, dear goodness. You did not get to see because I tried to skip through, but that was a lot of
I didn't touch it.
Okay, so now we have all the contents. Finally, it is 12 megabytes.
I think I saw
Actually
it.
open that as a line text now, get back to the base. Now we can see all of the values. It's using system text encoding, UTF-8, get bytes, get string from base 64, and then creates a script block. So what is this one supposed to be? Easiest thing might be to put that in CyberChef. So it'll take the ASCII values if they are ASCII values. Alright, let me put these side by side and try to make sense of this. The CN variable, do we see that one again? I think we do. Yeah. So everything that references this as a type, I want to replace with the system text encoding we have on the other side.
Here now,
Okay, so I think this is like just barely more readable now, where we have the bytes of the string AMSI result not detected, with a big chunk defined up here. That AC variable is the giant blob of values. That is going to be decoded from base 64 and then retrieve the bytes out of that. And then they end up getting a script block to execute more PowerShell code. You can see the invoke syntax there at the very end. Sorry, my face is in the way. After they XOR it with the AMSI and result not detected string. So could we get that value and then decode that out? What are they doing with the YJN one? That's another big blob just as well. Where's YJN in the mix? Oh no, YJN is that result, decoding that value. But we just need all of these values decoded with the AMSI result not detected XOR, right? I can cyber shell. Home character code is that. And then XOR, oh, that should be base 10 as well, sorry. With UTF-8 string, AMSI result not detected, right? Paste that in. That's PowerShell code. Let me just download that. I can save the output file. Download that is fine. Put that there. I guess that's what? Stage 6 now? Stage 6.ps1? That was agony, but I think we got the next payload. So we define a couple constants, and it looks like we're doing Win32 API stuff. Let me get word wrap on. Neat that we have an isReadable function to be able to check if the memory protections are nice. Pattern match. If we are using 2 of PowerShell, we define an assembly, we build out a couple of structs, we get a couple other function delegates to be able to do other Win32 API functions, so get current process, get system info, virtual query, read process memory, write process memory, probably all planning to do some process injection. You can see a classic and cookie cutter AMSI bypass, AMSI scan buffer ends up being built out, and then trying to break it to then eventually get our A defined, which is very, very likely a executable file. TBQQAA. That sticks out like a sore thumb as base64 encoded .exe or a portable executable. So yeah, we end up converting that, making that its own assembly, which means it's going to be C#, which means that we can mess with it. So let's carve out that .NET assembly. Let me go to the very top where all those bytes are defined. Let's grab this. I want to get the syntax here to just write all of it. This will be stage 6A.ps1, right? So let's use system.io file. And I think from there we can use write all bytes. And with that we can just give it like our stage 7.exe with all of the bytes, right? Yep. Now I'm okay to run that on my host in the virtual machine, right, of course. So let's run what is stage 6A, correct? Do it. Oh, yeah, of course. You don't want to run scripts, that's okay. We can set the execution policy to remote assigned. We need to do that as administrator, okay? Let's bypass that with stupid easy bypass. Totally malware, right? Stage 6A. Okay, now we should have our stage 7.exe. Back in Explorer, you can see that. Whoa, it's got a fancy icon. What is this thing? Shared memory sample? What? Original file name ACGPFB. Alright, well, let's get ILSpy or DNSpy or like .d so we can actually rip that apart. The defender deleted? Page 7 is not there anymore. Oh yeah, I did not like that one. You're a log stealer. I thought I had an exception with my folder. Put it back. I want it. Give me that malware. Okay, so .geek is done installing. Sorry, this is a new VM, so I kind of need to get tools. And the reason I'm able to open this in .geek is because I recognize this is an assembly with a managed assembly .net stuff, so you should be able to rip apart the flight code. Hopefully it's not obvious to be able to tell, but it probably will. I accept the terms. Yep, that's whatever. Okay, simply do it. Alright, I'm going to open up MP3 stage 7, named appropriately ACGPFB. Throwing down into that, we got some other shenanigans. I don't know if I want to deal with that. D do it? Yeah, I mean, we could also just run this now in our dynamic sandbox, like anyone, and Defender already told us, look, it's a update info. Oh, it loads another assembly. It's nested even more based off of this. Yeah, the P Pro will fit here. Will AES probably decrypt? Yeah, crypto scheme, AES create decryptor. So it probably has more nonsense. Alright, well, let's take the easy route. Let's just do dynamic. I think even just getting to the executable was still pretty cool. Like, that was what, like 7 pages? And it's really sweet stuff. Like, PowerShell add script, sort of like reflective thing that it did to be able to determine its own methods. And, like, even the MSHTA, like, window on error handler to be able to mask a bunch of other random nonsense. It's still pretty cool. Already being tracked as a llama stealer, huh? Doobie llama stealer, and Doobie. Those credentials from web browsers, as expected. It's like stealing your personal data, as expected. Llama mutex. Whatever. I went through a lot of work to tuck that one away, though. Connecting to acnestm.rust. And another steamcommunity.com. Wait a second, why? Main filter for stage 7 binary, connecting only to these. So just as we saw, it was like the first one that was executed, then just put together its own process running with its new assembly loaded, right? It ran it a second time. First one detects, hey, this is the stealer. Stealer has been found. There's a little bit of recon. Same sample info data. And the other one that gets ran, that's where they, okay, immediately detect as well package pairs. Then sending it to real Steam. But that's all, like, encrypted, right? That's all HTTPS, if you can see what that is. I want to know the real URL command, because they're probably getting that IP address from, like, where it's going to connect stuff back to, from a Steam profile. You see that? They do it all. Wait a second, what are these domains that you're trying to get to? Allsham.digital, all of this, stirpicker.digital. We can try to upload our thing now to Virus Total. Since we got stage 7 finally ripped out, use that. Okay, no, you can see before. Oh, 5 hours. Delay. How did we get that? Yeah, that lights up like a Christmas tree. Community notes, everybody saying it's bad. Oh, the Excited Group got it 2 weeks ago, just what I saw. Huh. What does hacknestm.run look like? Ah. Been through Tor? Bummer. All the DNS requests here though, Lashon.digital, begindecapper.world, garage roots, these are probably, you know, paid hosted spots otherwise for Llama Stealer, a lot of their engines. So that's at least some indicator of compromise, I suppose, but info stealer, you know? Another classic cookie cutter stealer. Hey, that's it. That's the end of the video. I don't think I can go particularly too much further. I don't want to deal with a lot of the obfuscated.net and C#, and some of the dynamic analysis, and even from the Defender alerts, you know, just another info stealer boils down to basically the same stuff we've seen all the time before. But I do really like, my goodness, what, that was like 7 stages just about? I don't know if you count our like A and B little suffix here and there, but look, we had the MSHTA trick, we had that from an MP3 file to start. We had this, and doing that cool little on-error handler to hide amongst a massive disaster code. Some PowerShell tricks here and there with that add script, little internal lookup of its own methods and functions. So I thought that was slick. So I hope there were still some cool little breadcrumbs, Easter eggs, a couple nuggets that were valuable for you and good education there. With that said, I'm done rambling. Hey, thanks so much for watching this video. Please don't want to keep valuable things like how to subscribe. Please do give some love to our sponsors. Link in the video description. And I'll see you in the next video. Dive into this video, I want to give a quick shout out and some love to our good friends over at Sneak. If you haven't heard, Sneak is hosting a free Capture the Flag, what they're calling a Fetch the Flag, on October 5th. The CTF is for beginners to intermediate players, and I've actually included a couple of my own original old school vintage challenges. There will be 20 challenges in total, including a few that I created. So hey, if you win, in addition to the glory and bragging rights that you can take home, you can win some awesome prizes. in there, sneak.co/John. And take a look, have some fun. It should be a great game. It's going to be beginner friendly and welcoming to just about all players and levels of expertise. Solve some challenges, learn some cool new things. And I'm going to be doing write-ups, of course. I'll be showcasing some video write-ups and solutions after the capture flag. But if you want to get the most out of it, you should totally jump in, go play, and try your hand yourself. The CTF kicks off on the first day of SneakCon, Sneak's conference on building securely. So participate in the CTF on October 5th, then stick around on October 6th and 7th for 100 sessions and more, including some live hacking workshops. Totally free, all online, virtual. You can register right now, link in the description below, and I hope to see you there. Hope to see you on the scoreboard, and I hope to see you soon. Hello everyone, and welcome back to another malware analysis YouTube video. I'm pretty excited to bring this one to you because I think this is an interesting little task here. I've gotten halfway through the portion of the analysis. I want to show you this nice trick, and then the actual quote-unquote reverse engineering or walking through the sample, I have not yet done. So there will be a little bit of tiptoe tap dancing, a little bit of improv. Don't exactly know where I'm going. It's going to be exploratory, going to be just sort of discovery-based. We're going to have some fun. But I think this is an interesting one because there's a little bit of a problem, a slight snag, and then a cool resolution that I think some of you are probably already familiar with, or else just might not be. So without further ado, I think we're already a minute into the intro. Let's get after it. I'm over here on my computer screen. I should be working in Redux or a Linux distribution to kind of reverse engineer and do this analysis, but I am just in my Ubuntu VM at the moment. Please forgive me, internet overlords. And let's see what we're up against. I'm in this directory called Reg, using Z shell and Z shell syntax highlighting using Hexa to display LS contents in a nice, beautiful way. And I've got a couple files. I've got the original command that was ran, and another interesting file we'll talk about in just a moment. But let me give you a little bit more background and pretense here. The original command was found in executed line post, set up as an auto run, right? Set up as kind of a persistent foothold, set up as an implant or rollback door to kickstart more code just on startup automatically and auto run, right? That original command was originally, I think, just an LNK file or a Windows shortcut file, and it tucked in more code that we will take a look at right here. I'll go ahead and cut out this original command, and the syntax that we see is invoking command prompt, cmd.exe /c to invoke one singular command as an argument to this command prompt window of kickstarting, and we'll start a new process. Now, the color syntax highlighting is a little bit messy because there are lots of quotes and weird minified compressed data here, right? It's obviously all just one big one line, but we're using quotes here to note the string of the process that we will start through the command prompt. We're using MSHTA. Now, MSHTA is that engine interpreter and program built-in native inherent to Windows that will execute other scripting languages kind of used with the HTML application stuff that Microsoft has. So it'll be able to run JavaScript, JScript, Windows dialect partition of JavaScript, or Visual Basic Script, AVScript, and other weird things. You can see it used a ton if I go ahead and Google up to ELDEN's MSHTA. There we go, let's fire that up. You can see used by Windows to execute HTML applications. MSHTA, involve paths, and a lot of good reading and research already done, but you could really be hunting for this sort of thing, trying to detect it by using raw or obfuscated scripts to the command line. You could have it execute an HTA file on its own, or you could pass in more code as a command line argument, just as we're seeing being used here. MSHTA.exe with a language and syntax to be used, Visual Basic Script or JavaScript, and you could also do some spooky, scary stuff with alternate data streams, adding things like colon after a file and other neat tricks. So if you haven't heard of Molden's, other incredible resource. If you haven't heard of MSHTA, other thing to explore. I think that's enough top cover on that idea. I'm sure you are more interested in the syntax. We're running JavaScript, and it looks like we're setting some weird variable names, ONK, DQ, Q7, totally random, to the letter N. U6Q, String, ActiveX object to run a JavaScript shell. Okay, could be doing some nefarious stuff there pretty soon. And then some other variable also setting other weird strings to nonsense. But ultimately, we end up evaling and executing code that's going to be present in that registry. Let me go ahead and do this. Let's copy the original command to like a stage 1. Just call it .js because it is going to be running JavaScript after all. Let's open that up, and I can turn on word wrap to make this a little bit easier for us to see. Super duper zoom in here, and let's cut out everything up until executing JavaScript because we know we are just going to end up running JavaScript as well. Adding new lines after each semicolon. Just doing this by hand manually because there isn't a whole lot to do. No point 7 lines. Let's go ahead and save this. Maybe copy it from stage 1 and so we rename some of these variables. Let's call this the letter N, not reused anywhere else. U6Q is going to be a representation of W script shell. And then we have another random characters, another one for more pairs, and then another one for other pairs. Super easy. So I was using Control-Alt-H, or excuse me, I used Control-H as a blind text to enter, find, or replace, and then I hit Control-Alt-Enter on my keyboard to find or replace all occurrences. Just some nonsense there. Code from registry. Oh, it's a little bit too much to read. So, ultimately, aside from some weird random strings that aren't used whatsoever in this snippet here, we're just grabbing more data being stored in the Windows registry and then executing it with the eval statements. So there could be dangerous stuff going on, it's just a matter of knowing what is in that registry. Now, if you're doing this in sort of a actual investigation or just kind of responding and trying to figure out what this might do or doing the analysis in an environment, right, you could very well be working with EDR products, endpoint detection response, or some sort of incident response agent. GRR, right, GRR, I think that's Google Rapid Response, I could be wrong. But oftentimes you might have a utility to be able to look for and search for these in one specific way where you're running as system. You have the ultimate godlike powers. Oftentimes, when you're checking out HKCU for the current user, you run into this problem where you're only going to be able to see the users that might be logged in because HKCU is not going to be relative to your running account system. I don't know if I explained that in a very good way. Let's grab a Windows machine and kind of show you what I'm doing here. I'll fire up regedit, right, or registry editor, and forgive me, I might have some stuff looking very clean here, but HT current user only refers to your user that you have. They're currently running, right, current user. There is HT users, which you might be able to actually reference and explore different users' current user key if you knew their SID or their user identifying number. S, tag 1, tag 5, etc., and the random string here. I don't think GUID is the right word for it, but that identifier for SID is the right word for that user. If you were to navigate in HT users under that user's SID, you could explore what would be in that user's current user file. The hard part is, if you are running a system and you don't have visibility on HT current user, you're relying on this HT user's time, but you'll only be able to see things potentially if that user is logged in or their user profile has been loaded. this. I try to Google around, as you should. We can get back into Chrome. We can be Googling for like view other users HKCU or current user registry Hive. And you might be able to see some super user tricks. And this is exactly what I ended up learning, and I would like to bring to you in case you don't already know this trick. It is literally just manually loading a user's key. I'm looking for a way to access the registry of another user on a computer so I can copy and work with that. The idea is that I'm trying to get kind of a background they don't need. I don't know the other user's password, so I can't log in as if we're doing run apps. And maybe this is the scenario you might find yourself in. If you're doing that incident response, you're working with some IR agent, and you're in this situation, what you can do is swipe that user's ntuser.dat file. And I'm sure you saw that in my current directory there. That's located in user profile. And that, in essence, is their HP current user Hive. That, of course, requires you to be admin for system and have access to the HAP file. But if you're doing memory analysis, doing forensics, maybe you might find that situation. Let's get back to my Windows VM. I'll show you that kind of in action. I will open up a command prompt here. And I am in currently my user profile. I'll show you that variable super quick. Yep, just the current directory, the home directory equivalent to Windows here. And I could run a dir or check to see if ntuser.dat really exists in it. I think I need to do like a /A to show all files. Yeah, there it is. Because that is hidden in a system file by default. So dir/A ntuser.dat. It could very well be a decently large file, a couple megs, maybe 4 megabytes, 6 megabytes. I think at the most I've seen is 6 megabytes so far. But you could swipe this file, grab it, and then start to play with it and work it. I can open this up and load it within Regedit, kind of like I had just read previously. You can see I actually have done this. I have a little leftover that I feel bad about. I have an Apples thing that I tried to load it. Because if you do this within Regedit, if you were to try and click on a Hive, go into File, you want to load a Hive. You might have saw a comment in that super user post that said, load Hive will only be visible and accessible for you if you are in HQ users or HQ current users. I think this is actually HQ users. So now if I were to load Hive, I can get to where I would have stored that ntuser.dat file. We'll open that up, and looks like it already has loaded, which makes sense because it's in that Apples thing. I don't know if I can unload that. Try to delete it. It's like, unload Hive. Yeah, do that. Thanks. Okay. Now back to users, load Hive. Let's pull the ntuser.dat file, and it'll ask for a name, like just a nickname that you want to refer to this Hive as within your local registry. It's not the actual name of something within the actual machine. It's just your local testing copy. So you can say I literally call it Apples. You can call it whatever. You can call it please subscribe. I'll call it test. Nice and easy. And it will load it. And then you can navigate and look around. I'm not going to end up showcasing this in all its entirety because of confidentiality reasons, right? But I think this gives us a little bit more runway because we can work with this. The hard part is that if we're viewing this in the registry, there could very well be a lot of locations and lots of huge, ginormous chunks of code and payloads of data that we can't readily copy out of Regedit by hand. You could, or you could do it manually, but it might just suck. So let's automate it in a different way, or try to get it so we can copy and paste things out in a sane way to do that. That brought me to this next conversation, brought me to this next talking point, where if we have this ntuser.dat file, how can we carve out all the data and information in a way we can use it on Linux, right? Because I was in Windows, but I really want to do my analysis on Windows because I'm a Linux guy. So you could be Googling around for registry extract tool, command line, or things like that, trying to look for things. Obviously, Reg Ripper is a great discussion and talking point. Maybe Reg Ripper would work really well for us. I think one that I wanted to get into was trying to do stuff with Python. Maybe I want to automate this or do more with it in the future. So I would Google around for registry extract tool Python. Pure Python parser for Windows registry hives, registry extract, WinReg, there's plenty of these. The one that I stumbled across was Regify, and I think I really like that one. If you'd like, totally feel free to explore a couple of these. This looks actually really, really similar to the same sort of syntax that I had seen in Regify, but totally Google around, totally explore, maybe see what they offer you or what they don't offer you. But I would encourage you to explore if you don't. Let's dive into Regify, though, because Regify would work really well for me. That's what I've played with thus far. You can install it super easy. Hit install Regify, and it is a Python library for parsing offline registry hubs. Exactly what we need right here. You can use it as a Python library if you like, or you can use some command line and dump an entire registry hive to JSON. And I'll show you that. Let's see. If I were to install Regify, I already have it installed. You can run that command and get your hands on it yourself if you'd like to. And then you should have a couple new commands. A command line, right? They're not strictly all called Regify. If I were trying to let Regify on its own, it's like, I don't know what that is. Sorry, dude. But by tab complete, just hit tab a little bit, it'll offer some examples for me or some options. I could use registry diff, registry dump, or just plug in all these things, and you can see these are a bit more defined in the Regify GitHub for the documentation. Installation discussion, the command line tool, you can parse headers, see some nice tabular output. Or you can dump an entire hive to the disk. This might take a little bit of time. And that's what I was originally doing. Right? I could just run registry dump on that end-user.dat file. Now, I'm not going to do that because, again, I don't want that all pre-displayed out on the screen. Maybe I could just snap it and move it to like DevGo or something. But that would literally, as the description in the README had explained, take a long time. Dumping out everything. Maybe you just want to specifically narrow down to the registry key that you work with, or HKCU software, etc. Now that we can dive into HKCU with end-user.dat, we can reach this. We can access the data that's there. Let me pull that out using Regify as a library, kind of as it suggested Python syntax. You can see it offers a lot of this here. You could initiate the registry hive object from registry hive, grab all of this. I could copy and paste that, but I know that I would get scolded from the YouTube comment trolls. I honestly don't think anyone would. It was making that up as an excuse for me to type it and feel better about myself. Registry hive. Let's do a dot slash into user. No, does that have? No, it doesn't. It doesn't have DAC. So they literally use this exact example. You check it out. They're using an NT.dat file. It's loaded in, and you could iterate recursively over the entire hive, or maybe we could do some other stuff. You can see the syntax here. With a reg object created, we can get a key or get subkeys, iterate through subkeys. So let me do that. Let me go ahead and reg get key. We'll use software. And just for a sanity check, let's just print this out on the screen to see if it works and runs for us. I'm using Control-V as a live text to be able to run that kind of on the fly. Looks like it does return an object for me, so I know that it succeeded, it got something. But now, let's try and get a subkey of this thing. RNVTTQBRN. That really weird sub. We know we're going to be working in HKCU to begin with. It is that hive specifically, so we can just use software as part of the path to retrieve that. Let me make that get that out on screen. We've retrieved that object, nice and easy. And now we can get a specific value. That should be that. Let's get value. That looked like, I think, some syntax we can use here. Get the values of the key, rolling over to the right here. Yeah, you can get values, plural, or can we just get a singular value? Value. That guy. Let's display that out on the screen. Okay. So see, exactly that is why I didn't want to do this in regedit purely, because there could be a crap ton of data and lots of stuff that you couldn't easily be able to copy and paste out of that graphical user interface. I am going to get values, just as a documentation of the text data. And let's see what else is in here. What looks like base 64, right? What looks like random characters that don't make sense. This is obviously a lot more data. You can see my vertical scroll bar over on the right here. There's a lot of stuff. So we have this experiment, a Python script now, to be able to carve out data. Let's try and get the value that we just saw previously. Before I do that, I suppose let's grab all of the values and then run it. There's that all. Let's redirect that to like an output.log file, just so we have it. And then we can use this utility as a little bit more of a scalpel to get the value for specific registry values. It looks like all of this is literally just returning the value itself. Yes. Okay, so I'm not seeing any of the tags like the name or the timestamp or the registry type, etc. All of this is just the reg value. With that said, we have this. Hold out and extract this. So now that we're over 20 minutes into the video, we've covered enough of the background, we've laid the foundation to be able to extract out the data that this malware might even use. Now we can get into the analysis. And we'll see where we go. I haven't gone down this road yet, so this is uncharted territory for me. If I fail more than usual, please forgive me. We'll call that stage 2.js, if I can type. And stage 2 is going to still have some of the variables that were present in stage 1. So we defined letter N in random characters as things that were kind of loaded before we run this eval state, even more characters. So we should take their original variable name and see if they're used or referenced in this next stage. Before we do that, let's word wrap all of this, and let's try to automate cleaning this up. I'll use a find replace it again to replace any colon or semicolon to indicate the end of a line or end of a command with a new line here, right? So now we can see we have a couple other variables set as strings of randomness. This looks like base 64, but I don't exactly trust it. I don't know if this other variable is even going to be used anywhere else in the script. We have this giant chunk of data. Here's this huge chunk of data. Maybe we can just ignore for a moment as we kind of continue on and see what else this code does. Looks like we define lots of other randomness, an empty string, and then we start a for loop, which it looks like I broke while I was trying to use the semicolon point. I don't see a curly brace following this for loop, so I think it's just going to end up running one command. We could go ahead and just add a new line for that, so that's displayed invisible. Then another chunk of defining other random strings, yet another new line character, or empty string, and then another for loop. This one actually does have a curly brace. It looks like there's going to end up being multiple lines of code in this. We start to work with things. Looks like do an XOR, have another semicolon, and we add stuff to it. Okay, and then we eventually eval that new table. So we've hidden something else. But all of these random strings, these variables are not used. So we should realistically name this to a clean stage 2. I seriously don't think we're going to end up using these. So we could base64 decode the data, like if we wanted to, but it's not going to be anything worthwhile. Like I really have a hunch this is just a random, the garbage data. None of these are used. So probably just trying to make a noise, add it to the problem, see if we can hide from antivirus, automated detection, stuff like that. We can nerf some of that out. We are using empty strings to add in different syntax. And I actually think this is used. That has a longer length than others, and you can see as I click on it, it is highlighting other variables here. So this looks like it's being used as maybe an XOR key, is kind of in the mix. But all this other stuff, nonsense, complete garbage. Kind of a waste of time there. With that said, we should grab the original variables that we defined. This guy being the letter N. Do you think that's even going to be used, though? No. Maybe those other ones will be used later. We don't know. But we can keep track of those variables that were defined previously and used. Let's set that up, actually. U6Q. Realistically, we should take this. Oh, I gotta do this. And then we can try and cut this up on our own. The red-green, though, I don't think we'll need, but it might be worthwhile to use it. So, with that said, let's go ahead and work with this thing. Looks like it's doing some XOR, and this is, of course, JavaScript, which means we can just let Node run this, execute this. We can just let this run without letting the eval statement detonate or execute the next layer of code, the next stage here. So let's take a, I guess, testing stage 2. And rather than eval, let's go ahead and console.log this final variable that's displayed out here. I don't think there's anything else that's malicious here. Okay, no, this eval is still present. We also wouldn't be able to execute that new ActiveX object or run this red read because I'm running on Linux, and Node.js won't know what to do with that. Those are specific to JScript and Windows. I think this is totally set to be ran with Node. So we have this testing stage 2 now, and let's try and run it. Now that we've declawed the thing, defanged the thing to not execute things with eval, I just want to see what the next layer of code would be that's going to end up being passed to eval. We got something. Ooh, I see some PowerShell usage in here. Whoa, we're going everywhere. All right, let's redirect this to stage 3.js. Let's open that up and see what we're up against. It's word wrap yet again. Let's try and clear out semicolons. Some new random variables. Oh boy. This does not look fun. At all. Oh, actually, wait a second. You know what? Maybe this isn't all that bad. More random strings. We try to move the window. We try to resize it. We get a new ActiveX object being wscript.shell, and we grab the environment. An environment variable? Is that what that does? Process? Wait a second. OELCXX, is that something that's present in the registry or in the process of implementing. Let's open up that log file we had. Oh god, this is horrendous. The OELCXXH is not present in what we would have seen in the registry, but it looks like it's just being set to PowerShell syntax and trying to execute some big base64 code. We would have to go ahead and move. Once that is ran, we go ahead and run C Windows PowerShell, PowerShell IEX, the environment. Okay, so it's just setting up some abstraction to hide this code and not store it on the file system. That's actually very clever. I think that's kind of a neat trick in the whole fileless malware buzzword, right? We have not written the disk other than that simple, excuse me, we sort of have between the original auto-run LNK file and of course the registry thing that we were able to retrieve from the file system with ntuser.dat. But this actual malicious payload, nah, dude, it's tucked away. It's hidden. So we've got PowerShell code here now. We're going to IEX and execute this text encoding, ASCII get string from base64, all of that, and then we go ahead and execute with IEX. With that said, we know that this is new PowerShell code to run. So let's call that, I guess, stage 3a.ps1. And let's make sure word wrap is on. We don't have a eval statement or an IEX or invoke expression here, but we are going to end up displaying this code out. So how many parentheses are going to be in there? 2, it looks like? No, 3. So let's tack in those 3. Now let's see if this will run the closing single quote, just like they have it. Sorry, my face was probably in the way. I was looking at how they ended this. So, once again, we can just use PowerShell to run stage 3a.ps1. And I don't know if that will output anything on its own. It did. That it did. Okay, so we're doing more weird stuff. Well, let's redirect that to stage 4.ps1 because now we've shifted to PowerShell. We got a new layer of code here. And this looks awful. But it has a lot of random comments. We sleep for 15 seconds. And then we try to define a couple functions. Now, all of these function names, I don't know if you can see them, gdelegate and gproc, these look like boilerplate structures building out the functionality to be able to run Win32 API functions. Where we could try and get a delegate, get a type, get a process, do weird things. Maybe we'll execute shellcode. Oh, some of this looks broken. No. We have gproc to get proc address. Yep, that's literally the command. It's literally the Win32 function that we're running. Trying to get a procedure. Get delegate will return types for us. All of these bytes looks like shellcode SC32. All of this here is shellcode that will be executed. Looks like we try to get delegate for function pointer to find the proc address of gproc for virtual alloc, so we can allocate memory. And then we use get delegate for function pointer memset, so we can make sure that that is going to be writable and executable and all that, and then we try and create thread to execute code after we copy all of the shell code into that allocated memory address. Spooky. Oh no, that the for loop is just for memset. And then we try some of it is broken with some weird representation, and that really bums me out. It's not null bytes. It's just weird stuff. Is that something that PowerShell like knows how to handle? Can I get into PowerShell super quick? Let me change the profile so it looks like I'm in PowerShell, and you know it. No. If I define these bytes, will it kind of know what I mean? I just took the first line of bytes, because it looks like that does include this BK, KJ, broken one. I truthfully just don't know what I'm looking at right now. Will that work regardless? I mean, it might. I mean, it might do it. 0x8b? That's the 139. And what would have been, so 5.7 is 8.7, 5.6 is 8.6, 5.3 is 8.3, and what would have been KJ, and that weirdness, is, wait a second, are those PowerShell comments? Am I just stupid? I'm pretty sure I'm just stupid. These are comments. You guys are probably screaming at me the entire time, you stupid idiot. John. Okay. So we have shellcode, and now we want to know what it does. To try and figure out what this does, we could write a shellcode file on our own, and then just have like Speakeasy try it. Let's try and get back to Subble. Let's create a shellcode saber.python, I guess. Let's slap all this in here, and let's remove anything within the stupid PowerShell comments. So those all get nerfed out. Okay, and then we can simply make this a byte array in Python. Is it the environment 0.3? So that would shell for 32. Let's try and import sys. So in Python 3, I can sys.centeredout.buffer.write to display that out onto the screen. Maybe we can redirect it or save it. Realistically, we could just do it with open SC32, write in bytes mode as filp. Pointer filp.write. What would we call SC32? Maybe? Let's try and run this real quick. Finished. So now I have this SC32 file, and it is supposedly data, but we know that it is shell doing weird stuff. In fact, you can actually see a load. I don't know if you can see it live. Rary, get rock address virtual alloc. So there's some spookiness in there. Maybe we could actually see what this is doing with Speakeasy. I have to remind myself on a syntax for Speakeasy just about every time I use it. So if you haven't heard of Speakeasy before, I don't know if I've showcased in the video. I feel like I might have at this point. But it's a portable modular binary emulator designed to emulate Windows kernel and user mode hardware. Instead of attempting to perform dynamic analysis using the entire virtualized operating system, we'll just emulate specific components of Windows and let you kind of see and figure out what shellcode might be doing. You can play with it. If you can do neat stuff in Python, and realistically we should do that since we just did some fun things in RegPy. But if we were to emulate Windows 32 shellcode, Python 3 runs play with that a little bit more. I know we're about 40 minutes in the video, and I am distracted with other things, kind of beckoning my need. So I'm going to pause the recording for now, hopefully play with just a little bit more, and then I'll try to clear things back up and hopefully get more luck with running Speakeasy. Hope to get back to you in just a little bit. Hi. Hello. If you can't tell by the change of shirt, change of lighting, change of me, it's been a day. Been 2 days actually, and I got pulled away from working on this, trying to report it because I had to do some other obligations, and now at this point I really want to offer some closure because I did tinker with it, I did play with it just a little bit more, and I wanted to include that in the rest of this video here. So please forgive me for the time travel, but let me show you really what else I kind of got started with in this tinkering here with the rest of that, and trying to get Speakeasy to play nicely. Gotta be honest, I never did end up getting Speakeasy to work with our shell code. So remember, we had this SC32 file. It is just data, because it is, of course, shell code that would be executed and kind of interpreted, or really ran and executed on the fly. But when we tried to run with Speakeasy, we were getting a lot of errors. Now, you could open this up in Hydra, you could mess with this, try to finagle it in Speakeasy, and I was thinking, okay, cool. Truthfully, let's just try and do what every individual might if they're stuck in a bind, and I would recommend this to folks. Ask for help. Check in with your friends, check in with other researchers, check in with other nerds and other geeks. So I will, in full transparency, showcase a conversation that I had with Caleb, a good friend of mine, fellow geek, fellow nerd. A lot of folks that might watch this channel and watch some of the stuff that I do already know the individual. We do a lot of projects together. He's a very, very close in real life IRL friend. But let me show you what we were doing, because he is a genius, much, much smarter than me, and I will be completely honest. You have to go ahead and really respect folks that are doing some great stuff, and they have their own technical prowess and their own skill sets and competencies. Not everyone, especially myself, is going to be good at everything. So I thought, hey, Caleb, do you think you might have anything to offer in this regard? I messaged him like, hey, have you used Speakeasy before? He's like, no, I haven't. It's super cool. And I said, it's really nice when it works. I've seen it do incredible stuff. We just like dump interpreter information and show what it's calling back and use the Win32 API call functions, etc. Sometimes I get an error though, and it doesn't work. I don't exactly know what I'm doing. So I was like, hey, if you aren't busy, I gotta ask. I have this shell code that's defined in PowerShell, but it dies when I try to use it with Speakeasy. And I included a screenshot there. And he's like, oh, cool, all right, hey, let me play with it. Just give me a moment. And then he used this bash to remove all the comments and get the shell code out of it. A really cool one-liner. Same thing that he used to do. He loves those one-liners, right? And I said, hey, just checking strings. This thing likely reads from a registry key. Maybe the invalid read that I keep seeing comes from just not having an emulated Windows registry to pull things from. And I see, oh, he uses unhex, which looks like a tool present in actually Pwn tools. Let me showcase that. If I were to use unhex on right now, it's just going to give me an input prompt. But if I hit Control-C, you can see that it dies trying to use Python's Pwn tools. So that's gotta be Pwn tools. It's pretty slick. Probably the same as like XXD tag R tag D to unhexlify something or decode it from the hex representation base 16. So like if you didn't know it, good handy stuff. He says, their Docker file seems to be broken, so I guess I'll mess with it. I didn't have any issues trying to load up the Docker file. If you wanted to, you can move into Speakeasy, and then you'll notice that there is a Docker file present. You can Docker build tac t, whatever you like to call this, Speakeasy, and then the period for the current directory, and then you can Docker run it and work with it. just kind of as Caleb noticed, and I was kind of referring to, we could see segments of some strings that could be executed. Load, library, get proc address, virtual alloc, exit process, kind of chunked up. So those are peculiar and interesting to me because obviously it's going to very likely do more things with more shellcode or executing something new, I have to think. I also see a reg open and then a potential reg key or query value odd and weird, right? But down below, I noticed that same registry key or sort of hive location that we were looking at previously, RNIB, TTQ, BRN. And this LPMF was some value that we saw in the registry file. I think I saved that in output.log, right? Yeah. So forgive me, I know this is disgusting to look at, but check out that value, LPMF, and the value that is included here is all of this. Absolutely nonsense, disgusting stuff. So maybe that's more shellcode. It looks like it's encoded in some weird way. It's not all real bytes. It's not an MZ header to kind of act as another PE or portable executable or Windows.exe or DLL. So I thought, well, okay, maybe this is something, maybe that's shellcode, but I don't know. If I try to carve that out, would it actually be more shellcode that I could potentially work to speak easier and even? With all that said, I was looking at these strings here, and I thought it's odd that they're kind of separated and chunked up with different delimiters or different pieces surrounding them. Obviously, it's not the full line load library. So I thought, let me just kind of look at this thing with a hex editor. I'll use hex edit SC32. And then over on the right-hand side, you can see the ASCII representation of some of these fragmented portions, right? Library, get proc, my face yeah, address, virtual lock, etc., etc. So scrolling through this, just trying to see if there was anything else weird in here, I saw this one peculiar thing, and of course my face is absolutely in the way. So let me show you how we could view that otherwise. I think strings EL does it? Yeah, that's it. So strings tag EL makes it take the Unicode representation. Let me check out strings. The man page here. Tag E encoding. Pass in an argument here. Select the character encoding with the strings that are to be found. Possible values for encoding are S, single 7-bit characters, that's ASCII, etc. That's the default, as we just normally ran strings. S, B, etc. Oh, this is it. L is 16-bit little endian. Useful for finding wide character strings. So we found that just knowing that magical incantation with strings, but realistically we could end up using something like floss to be able to track them down. Do I have Chrome open? I don't think I do. So floss GitHub, please. This is it. Just like Speakeasy, this is another FireEye utility. It is the obfuscated string solver. Basically strings, but just amped up to be able to look for static strings, advanced static string analysis, trying to find things that might be present on the stack, etc. Trying to do other things, and also finding static UTF-16 strings. That's what we were just examining. So if I were to literally run floss, if I've cloned and installed my off directory, floss on SC32 will give us this static Unicode string. And that has an interesting syntax here. Shell, colon, and then kind of arrow keys, or the greater than less than symbols, waka waka, whatever you want to call them. A strange syntax here. Then I RM. So I didn't exactly know what that was, but it looked weird enough and unique enough to be something that maybe we could key off of and do some more digging and research. Because maybe that is one specific telltale that could help us diagnose and really detect what this malware sample is. So with that said, I go back to Chrome and I try to Google that sort of thing. And I get some weird stuff trying to find Shell gas stations nearby. I'll have to be sure to obscure that, blur that out. And the other results that it sees here are ADB Shell RM, how to remove file on Android using assume that RM syntax up here is like making stuff weird. Let's Google that again without that. And that doesn't get anything worthwhile. Let's try and remove that RNIV portion. See if that does anything different. No. Part of me thinks the shell thing is going to be cut up, so let's try and just add double quotes around that to see if maybe like it's searching for that literal string. And I have some weird thing here that returns Cupter uncovered. E. White has a deep dive analysis of Cupter, a quick fraud malware that was the #1 source of new primeware infections in May of 2018. So let's go ahead and take a look at what that thing might be. Looks like it's a PDF to download. I want to open this up here. And we have Cupter uncovered, malware teardown. Maybe the sample that we're looking at is Cupter here. Table of contents kind of explains this sort of thing. Overview of Cupter's behavior. And then here, what we're talking about, abstract. E. White has a deep dive analysis of click fraud malware, #1 source primeware. Cupter's fileless persistence technique, which exploits bugs in the Microsoft registry editor to write invisible keys to the registry, is also discussed. Okay. So this originally, I think, had been found by a malicious Word document or embedded Visual Basic script, VBA application, download malware from the C2 server, click fraud malware. Is this what it will do once it executes? Probably. Before diving into the technical detail of how it operates, the section will explain the overall behavior of the malware. We'll walk through all of its behavior from when it first begins execution to when it begins, like fraud activity. Cupter uses several clever tricks to achieve fileless persistence on machine effects. The machine performs a variant of common technique, adding a value to the register key, HK current user, software Microsoft, Windows current version here. That must be the actual auto run, the LNK file that we had tracked down to like kind of kickstart our investigation here. Yeah. This causes a two-headache, suspicious values in registry, and the red key are often a red flag. Location malware is exposed. Cupter overcomes both of these obstacles by creating a registry value that is visible to Red Hat and storing its malware executable in the registry. The hidden value of the red key is a short snippet of JavaScript, which is passed to the Microsoft HTML host, MSHTA, as a command line argument. That script decodes the next layer, all of which is stored in the registry, instead of an executable on disk. Ooh, that sounds kind of like what we were looking at. Sends messages like rest bot okay, further mislead malware researches. That must be some communication once it actually has like its full payload unravel, communicating with the command and control server C2. Huh. Okay. Using Chrome to be able to click on other things, using a modified version. I'm not extremely interested in this. I kind of want to get into how this all kickstarts. Is this going to end up being the same malware sample that we were looking at? Oh, but the context strings it references here that looks like we're part of communicating with the C2. It does include that shell syntax that we just saw, used when a shellcode 32 or a C32 variable that we just saw loads Cupter. Causes Cupter to inject itself into a new process with process hollowing. In order to reference the process it will use the host our reg server 32, Explorer, run DLL, and the process Cupter is currently running. Crazy. Let's see. Configuration data in the resource center. This must be what the shellcode is trying to execute out, the C32. I'm assuming. It's responsible for parsing the PE resource. After the data is base64 decoded, a 16-byte XOR key is pulled down from the data which is used to decode the rest of the buffer as seen in the following algorithm. XOR, which would be in the PE file, I think, if I'm reading that super quickly. I don't think I need some data to that. Configuration data in registry. This looks looks identical to what we would have seen had we opened that thing in registry, because of these strange variable names. The screenshot above showcased an example of Computer's registry configuration data. The random-looking names are the result of a name generation algorithm Computer uses not only for registry names, but also for naming files it would write to disk. While the names appear random, they're actually deterministically generated. Each value above starts as a clear text seed string that is salted with values from the affected computer, which is the computer name. The campaign key is also used as a salt. In the above screenshot, the key containing the rest of its values is IIID. This is generated by the function generate unique computer name and is referred to the unique computer name elsewhere in the paper. Oh. That, I'm going to assume is that, would that be our LPMF equivalents? Or where we found this original thing? Let's go around, registry values. There's some tricks here. I didn't see any plain text user agent, not gonna lie. But this might be new variant or something. I think Computer was doing some Jupyter tricks, or Jupyter was doing some Computer tricks. I don't exactly know. Though many IP addresses are stored in the registry and Computer's resource segment, most of the addresses are not legitimate C2 addresses. The address of the actual C2 is stored in reg value 32. This registry value contains a domain list. The address in this list are stored with the prefixation P. All communication with C2 occur over SSL. Or 443. Understood. Let me see what JavaScript you guys see. Let me see what you had found to showcase this. Are you not going to show me? No? This is a very cool graph here. I don't mean to completely score right by it, but update executable context things. Runs MSHDA. Does all this. Process autoing, double loader, regular P loader. That's crazy. That's a very cool graph. What else we got? Fileless persistence. In this appendix, we'll discuss Computer's fileless persistence technique. The techniques that allow it to take advantage of weaknesses in registry to create invisible things. Ooh, this screenshot showcases it. MSHDA, JavaScript, random value set to random string, something set to a new object of WSH, WScript shell, and then reg read, HPCU, software, random thing, email. That's exactly what we were just seeing. Large hex string is XOR decoded and passed to a second JavaScript eval function. Meaningless JavaScript variables are created and intermixed with the XOR decode algorithm. We literally saw that exact same thing. Okay. Stage 3, the A64 string is decoded and passed as a environment variable to PowerShell, which calls IEX or invoke expression on it. Again, literally saw that. Two functions are defined, gdelegate and gproc. Exact same. These resolve virtual alloc, allocate a read-write executable buffer, and copy a byte array called SC32, and then create thread passes control the buffer and execute. Wow. Again, identical to what we're seeing. So I think without a doubt we can pretty confidently say, look, this is Computer. Explaining all of this, they do reference an LK file, which would be what we had tracked down. They also saw a bat file in their case, or a specific extension to be able to run and execute the spooky actual Computer payload. This is their batch script syntax. That wasn't one that we had seen, but it ends up creating what it sounds like a handler for that specific random file extension. The start command uses the default handler file extension to run this file, but the malware would install a default handler for that file extension. It'll add that in HD class roots. That's not going to be present in our own registry, like Hive that we got from NT.dat, but I wonder if it is on the target. And you can see the JavaScript syntax with MSHDA. Blah, blah, blah. I think I'm beating the dead horse on this. I've been doing this for a while, but seriously look at how identical all of this is. exactly what we were up against. This truly is Counter. We can see all the same tradecraft techniques and real syntax here. I'll scroll through this a little bit more just to see, yep, G delegate sleep for 15 seconds. All of the Windray 2 functions are being able to be pulled in. SC32 bytes with the comments, just as it found. And, this explains it a little bit more. PowerShell script is a large byte array called SC32. The script allocates a buffer of RWX memory. SC32 can be extracted from the script. Strings like byte, intermix, array are comments. There's obvious data. It took me a while to realize that. Thanks. Once the shell code block is extracted, we can analyze IDA, EDRA, or whatever. Yep. Shell code reads the registry value, just as we thought. It's a buffer containing the counter PE file encoded with an XOR. The key is baked into the data section of SC32. So that must do some XOR, because the data that we saw on this is just too messy. Not gonna lie. That's not something that I think would very easily be able to be pulled out. At the time counter persists itself, a random string no longer 32 bytes long and 16 bytes long is generated. Counter is encoded, and that string uses XOR decode in string 2. The key is burned and embedded into SC32, and the encoded counter is written to that registry. Counter is loaded in the same address space as the shell code. We're still executing in the context of PowerShell. SC32 uses the counter key loader with double size allocation, so the counter key and context strings here as well. The string shell RM, and then the unique computer name identifier, NCAX in their example, is used, and that must do the process hollowing technique. When Giant sees the shell context string, it uses the context string power and does process hollowing to inject into the process. The sleep in PowerShell script in the third stage, that's that 15-second sleep, that allows us to see PowerShell terminate and expire. But the power context string causes the process to activate counter process. That's insane. It talks about the invisible registry tricks, it talks about conventional persistence, but using HK current user is a little bit of a trick. That's why we're jumping over hoops and hurdles with the ntuser.dat stuff and other things. Trying to access something wouldn't be displayed in the registry if you're looking at the original auto run of the MK. Very slick. Very cool. Very spooky. Good malware tricks. And Counter, I think, has a lot of tricks up their sleeve. Alright, I've been scrolling through this for forever, but now that we know that this is Counter, we can do some Counter malware analysis, and maybe do a little bit of other reading, and you can see that I've went around and just tried to uncover what else is described here, what else is showcased. Trend Micro has some info. Again, this is previous research, right back in 2017. Let's see if this explains a little bit more. App data recovery, and that is used in demo. It's not all that helpful. I would like a technical analysis. Can I go back to Google, please? Malware analysis. Go that one. Here's one. It's the Malwarebytes blog. Merch has some good stuff. Analysis of Viper. Quick Heal. That's another PDF. CDN HubSpot. There's a lot that could come from this. This is Malwarebytes Lab. Counter is a click fraud malware famous in everything that we've already read. They work through a couple samples. They showcase a lot of this stuff, MSHCA over PowerShell, etc., etc. Trying to unpack and extract some of this stuff up. Okay, they're using a debugger to analyze these. You can see the PE file that we would end up carving out. It breaks for them just as well. Is it packed? Persistence talks about the invisible run keys. You can still see auto runs. The batch file, the persistent file handler that they've set, the original MSHTA one, how it would look in registry. I'm cruising through this because I want to see some other new particular tricks. They or how they might have figured out how to carve out the PE file from the shellcode. It sounds like that SC32 is position-independent shellcode. Content is loaded into a newly allocated memory page and executed a new thread.
Here,
You can see it, they examine it in their debugger. Every shellcode must be self-sufficient in loading all of the required inputs. For this purpose, this one uses a trick. Scroll through that, sorry. What? Did I jump past it? Yeah. It uses a trick known from the reflective loader and shellcodes generated by Metastar. Okay. At the beginning of the execution, it tries to hit the handle from kernel 32. To achieve this goal, it enumerates all loaded modules, calculates checksums of their names in comparison with the hard-coded checksum value. Then it uses checksums enables the functions inside of kernel 32.dll. With their help, it loads other necessary modules and functions, i.e. ADB. Part of me is curious how that might... Oh yeah, because that's how we would need to get the registry open keys. And query, it needs to pull them in from ADB API 32.dll. Using the checksum functionality and being able to get like unique identifier for each of those is actually what they showcase and teach in OSED, the Offensive Security Exploit Developer. When you're handcrafting and writing your own shellcode from scratch, you do this exact process. You generate your own position-independent shellcode with the techniques from the reflective loader that Metasploit uses. Kind of a neat thing. They try to export it, they try to get it. The value that's stored in the registry is read in memory and encrypted. The encryption key is random, newly generated on each one of the installs. So it's going to be specific to our own instance of code. Turns out to be PE file was loaded before, and then you can work through and extract it. It doesn't explain a little bit more. Because how is it decrypting? How is it showcasing? Here's another article.
And grant peace to these two parties.
I want to get a better feel for how it might extract that E file from that big registry. All strings are kept in a structured, encrypted form. The string is decrypted whenever required and erased from memory after use. For string decryption, Cover uses RC4.
Lord of seasons.
That's new intel. Because originally I think we were thinking it's XOR. All encrypted strings are kept in the control section in the following format. Below is a snippet of the encrypted string structure. So they have a separator with FFF, FFF, and then a keyword, a key, and another separator. Maybe we could see that present in our shellcode. Encrypted key, or the key is generally 3 bytes long. For each string, the key is different. The keys are simple. And then they analyze some of the network traffic. Oh, and you can see the click fraud here. You can just try to click on advertisements, configuration. This would be a very cool one to look through just as well. On their certain config file, you can see all the different potential domains. Wow. Wow. So, with that said, let's kind of go back to what we were discussing with Caleb. And I'll pivot back to this. He's smarter than me, right? And he opens the thing up in Ghidra. And he says, looking at this code in Ghidra, it appears to manually resolve the addresses of load library and other things, and then uses them to load ADB, and API. That makes sense because instead of much of the registry, we processed that. It doesn't get that far though in our speakeasy emulator. It fails while trying to dynamically or manually resolve these sentences. And I said, look, I see all of these library input headers, etc. And it tries to read out this key in registry, that LPMF. I don't know if that's a binary or not, or shellcode. And then Caleb is still trying to reverse engineer it. He says, hey, it's getting more readable, but it looks like what we're going to end up seeing in that registry key is more shellcode, maybe. And I say, well, what I see in the registry, LPMF, doesn't have the usual MZ header. So it's not a regular key or Windows executable or DLL. I think it's more shellcode. It's just humongous. He said, yeah, I wouldn't expect it to. Loading an actual PE file from memory is not only difficult, but also excessive. As we come to find out, I think we see it is in fact literally a full-blown PE file and executable. I can see it allocating the space for loading the data in from one of two registry keys. one fails, it tries another, but I haven't figured out how he uses it yet. And then I said, the supposed shellcode that was present in LPMF gets nothing out of speakeasy. I tried to carve it out. Is there anything in the shellcode that uses, looks like it might use an XOR? That's what it's encrypted or is encoded in some way? As we were just doing our own research just now, we've come to think, okay, it could be XOR, it could be RC4. There are a lot of other random values that are in the registry, so I was wondering if any of those are a key. We saw some of the smaller ones. Like, let me look for value equals. Here's the original code we saw, K, Q, H, Y, etc. But searching for other values, there's one SDET, which is tiny, maybe that's a key. TGBU, maybe that's a key, etc. Maybe that's a key. Can I set syntax highlighting on this, please? Sort of, okay. Now word wrap is but I started to mess with some of these and basics before we code them and try to encrypt or decrypt with XOR without as a key. Didn't really get anywhere. I'm just a fool, not opening this thing up in key code, but whatever. I don't care publicly for myself. And Caleb says, look, there's definitely something going on that's doing the XOR or some sort of encryption or decryption. He hasn't gotten through yet. And then I shared with him a Contra white paper that I found at the moment. He says, that sounds like what I'm looking at. Surprisingly, they chose to dynamically link a full executable key file at runtime. That's a pain. They said it would be cool to try and dig out the XOR key and unravel the full key. He says this is probably the loop that does it. Following those memory references backwards with the L is really annoying. It says the key isn't directly in the binary. It starts off as random 256 and then is mutated at runtime to produce the final key. I was thinking, is it stored in registry as part of the persistence? There are those few short strings that might be candidates. I try to copy and paste that there. He says, the shellcode appears to dynamically generate, but I'm not done. So one of those might be used as part of this stuff. Maybe one of those registry keys is, but it generates the initial range at a specific variable and then mutates with the data as another variable. But he can't figure out where that second one is initialized from. Eventually he says, hey, I found the data, but I'm getting an index error. We'll try to generate the key. I was like, are you working in Python now? He's like, yeah. So this implementation, that loop that I'm showing you, looks like this in Python. We could grab the values or variables that he would have situated, and this is going to essentially be the same algorithm that covered used to grab, get the key and decrypt things that's needed. And eventually he's like, oh, actually, I realized my mistake. 1 second, I'm good now. Why did you show that? He says, did you already have the registry key extracted? I'm like, yeah. I pulled it out. From reading of the research, I'm not sure if it's XOR encrypted or RC4 encrypted. I'll go ahead and send you the log. And this is really cool. Caleb says, now that I'm looking at the Python code that I wrote, I'm pretty sure it's RC4, which is really just a fancy rotating XOR. So I showed him the code that I had used to carve this out. This was, again, using regipy as we had previously. I grab the LPMF value and I just write it, and I encrypt it as, or not encrypt it as totally not the right word. I encode it as bytes to UTF-8, and now I have that binary. I think UTF-8 is the right encoding here. The registry was a ton of non-ASCII characters, obviously, because it's encrypted with RC4, but I'm not sure if I'm re-representing that data that way. It's like, did you get a key? And then he just sends me an executable file. And the work is done. Caleb has done it all. The genius. I says, I'm surprised Slack let me upload that here. I'm surprised Defender didn't trigger on that for me, in all honesty. I said, how did you crank out the key? He said, what I identified as the unknown C was the RC4 passphrase. What I was reversing was the key generation algorithm for RC4. After I reversed it and rewrote the block in Python, I realized it was very similar to RC4 key generation decryption. There was a bug somewhere in my accidental code, what he was trying to write. So on a hunch, I just thought, hey, let's throw it into a real RC4 encryptor that is properly implements this with the unknown C value as the key, and it worked. So there he has. Now, my home rule bug riddled RC4 implementation gives us that. But I'm saying, how did you track down that unknown C value? What was that? This is the RC4 key scheduling algorithm, the variable unknown C that I obviously named. It's a stack local variable, but I cross-referenced it to find where it was assigned, and I found the second picture. I had to figure out the function being called as memcopy. This is an indirect call to another part of the shellcode, which implements a crude memcopy routine. So putting in and placing the shellcode, right? From there, I knew the key was at key name at that offset, and the actual key length was in key name at that offset, which are both memory references into the shellcode block itself, so he was able to extract those values and then pull things out. Very, very cool, very slick. The last part of the shellcode is just doing the dynamic linking required to load a PE file without consulting the kernel. It has the entire PE file itself in memory, so it has to go through and load all of the required DLLs referenced to the PE, resolves the requested functions from the DLLs, and then patch the PE file in memory. In the end, it just calls the engine. This is the same thing that the kernel would do when you call create process on its own, but they do it manually, so it doesn't create a new process. It just takes over this one, and it isn't logged as a quote-unquote new process. I commented this and was like, that is exactly process following. That is process following. That's kind of crazy to see that. What language did you tell Ghidra the shellcode file is to open and get a pseudo decompile display? I tried to pry it open, didn't have to pry it up to the right side. So a couple of things. Ghidra won't decompile arbitrary assembly in a shellcode, right? It decompiles functions. If you load the PE file with any x86 language, it would show up. It doesn't decode a disassembly. If it doesn't show a disassembly immediately, you can just right-click an address to contain the instruction and then tell it to disassemble. That'll give you a disassembly but no functions to decompile. If you know something is a function, right-click on that first address and click create function. It'll create a new function there and should kick off the decompilation process. Secondly, because this code is for Windows, you need to select the Visual Studio option. If you don't, calling conventions will be wrong. The function calls will look super weird. It's like, this is super cool. Thanks so much for helping me out, dude. I think this is cool. Let's showcase this a little bit. He's like, hey, no problem. This is an interesting rabbit hole. With that said, I have this stuff that I can show you. Let's try to fire up Ghidra. Just so I can show you kind of what I was getting at in that last segment there. And I know this is becoming an egregiously long video, and I apologize for that. Hopefully we'll have some pretty cool stuff in here. I have this SC32 file that I loaded to the project, and if you actually were to load it up, without it, it will prompt you for the library, and you'll have to select for the language. You'll supply x86, and then, as Caleb mentioned, Visual Studio. Now, hopping over to the functions segment, we're checking out strings, which we can see present. Clicking on the functions will actually let this, like, being the first one, show a little bit of a decompilation, and then we just kind of have to figure it all out, though, which is a little bit of a mess. But you could potentially see some of the same process that we were seeing earlier, that Caleb was showcasing, and the hex strings that will represent those fragments of load library. So not just load or library or area. All those are cut up in their own hexadecimal representation, so it's not stored strictly. It's very cool, very slick. I won't go into that witchcraft at the moment, but let me show you that binary that we have uncovered here. I try to chunk things up when I try to experiment things with different keys. I pulled out an encrypted one, and I think I actually got that from experiment.py. I can show you that microphone is still present. Yeah, I just carved this out with that same syntax you saw earlier. And then, like I mentioned, I was trying to carve out some of the keys on a hunch, hoping they might be it, but they were not. We do have, however, this LPMF counter.exe, which is an MS-DOS executable, MZ for MS-DOS. Now, if I were to again run floss on this sort of thing, let's try and fight that to less. Program must be run under Win32, W32. Because it's MS-DOS, it does a strange thing. So scrolling through some of these here, you can again see pieces to be able to use the Borland compiler. I'm assuming this is going to be a fragment of Delphi. We can open this up in Ghidra if we really wanted to. There are other things that we could reference here. I want to get to some of the unique, interesting ones. Yeah, Delphi, etc. Somebody keeps rolling until I can find something peculiar for us. Because a lot of those bot commands, like the articles that we were reading and the previous research that we were checking out, it looks like you could see those straight bot commands written in. And the track down the IP addresses, but again, that's in registry. With the key that we have, part of me wonders if we would be able to retrieve that now and see what C2 servers it might be using, or I don't know if it's going to end up being a different key. As I said, sometimes the key is different for each thing that's trying to encrypt and decrypt. Maybe we can get Caleb back in the party with us and see if he can jam and crank out the other one. But you can see the portions of the previous JavaScript and PowerShell things we would have seen, or how it used to set up its own persistence. Crazy. Putting all these in different registry keys, etc. These are all just fragments in there. But let me see if I can find one of those colons to showcase some of the bot commands that might run and execute with the command control center. Colon 32, etc. Ooh, fingerprinting, Windows Server, some things. I don't need to delay and badger this thing. I know this might not be all that interesting. Let's kind of see if we can get any indicators of power colon, or any colons that might help us find something that looks like one of the C2 colons. Should those both blanks? No. Maybe I'm not ready to see one. And there's a lot in here, so that could be helpful. And again, we are just literally looking for strings, not all that interesting though, so let's bail on that. You can fire that open in Ghidra, you can crack it open. You'll notice, or remember when I was chatting with Caleb was kind of surprised. I'm surprised Slack let me see that. I'm also surprised when I tried to download it, I was working with my host, and Windows Defender didn't care. So is this executable itself something that maybe would have some issues here? How does that look in something like Virus Total? So let's fire up Virus Total and let's see what we have. If I were to upload, we can upload our shellcode. Let's start with that. There's probably no way that we'll find anything weird. I'm not exactly positive. I really doubt that it would. It's just straight shellcode. I don't know. Oh, hey, ESET's like, hey, let's cover. Nice, ESET always gets it. ESET's pretty strong. With that said, I just for the sake of curiosity, nice, ESET's the only one that tracked it down. I did try to upload this previously because they're executable to Keelback, because this has been a few days. So Gambit was the only one that covered it, but he didn't know strictly that it was covered. Just an unsafe AI score. Can I reanalyze this file? Because it's been a few days, right? Now Virus Total might have passed it to other vendors, because Virus Total has to do that. For 1 out of 37, 1 out of 57, 1 out of 58, I don't know. I'm surprised that ESET finds the loader, but doesn't seem to track down this MS-DOS file on its own. So, no. Still, now a couple days later, with one occurrence out of 60, Defender let the thing cruise right on by. So I never want to exclude that. But I don't know. Obviously, all of this is just an exploratory thing. I don't mean to speak with any certainty, but it's been kind of fun to explore and dig into this thing. Cupter was very, very fun to walk through, from that initial persistence, carving through MSHTA and JavaScript and PowerShell, to looking at the shellcode. It looks like it has kind of carried itself around in different ways, between macros that are being used to infect the machines, phishing emails, right, of course, VBA scripts, etc. There's been a lot of cool research on this, and Cupter's been doing some weird computer stuff, even back in 2017, 2018. I would encourage you, if you're interested, go do some of that research, go explore, go look around, see what you're interested in. But there's a lot of good stuff out here. So, yeah. That's it. I am poured out at this point. I've been talking for a long, long time, and I hope this has been I know it's been a crazy long video, but I hope there's been some cool, good learning lessons in that. So thank you so much for watching, everybody. Thank you for putting up with the time travel between a few days ago when I started recording this, and now I'm trying to finish it up. The editing might look weird. Maybe my enthusiasm and energy is different. I don't even know. But thank you again and again. And please do those YouTube algorithm things. If you would like the video, leave a comment and subscribe. I'll be super duper grateful. Hey, I am trying to boost up my Twitch Facebook, Twitter, trying to handle all the socials. Would love if you'd be willing to come hang out and track me down on this hardcore. Hey, I'm going to include a shout out in this video for the Sneak Capture the Flag and conference coming up in October. You should absolutely go play. Please do it. And I'll see you there. And I'll see you in the next video, everybody. Thanks so much for watching. I love you. See you later.
is, of course, a Windows executable, but it is also a mono.NET assembly. That means we can kind of peek and kind of peel behind the layers, look behind the curtain, and see what that thing is actually made of in something like DNSpy or ILSpy. So I actually wanted to get ILSpy on this Linux machine, and then it's like, oh no, you actually need to end up using the Avalanchia, or I honestly don't remember how that's called and pronounced, but that's the cross-platform edition of ILSpy. So I'm like, all right, let's just roll it up in Windows then, because we have that. We might be able to do some other cool fun stuff. So let's hop on over to that Windows virtual machine, and I've got this terminal here. My laptop that you might have saw in the corner is actually hosting a web server right now, so we can pull down that Kaspersky.exe and those other files. So laptop, desktop, working
parsing, so that pulls it down without a problem. Just kind of make that full screen, sorry. There we go. But it wouldn't have saved it because I didn't specify an out file. So let's run that wget command one more time. Let's specify an out file, and we'll call it that dispersed.exe. Okay, now that should be downloaded. Good. And I also want to get that update.exe because we are going to explore and take a look at what that thing is. Perfect. And they should both be on my desktop now. What is that? What is that icon? I feel like I've seen that icon. I'm just going to open that up in File Explorer, so it's behind a white background. Kaspersky with a B file description and version number is 1.0.0.0. Oh, okay, fascinating. Let's just steal that picture and let's see if we can like do a Google image version. We'll just save it with paint. I'll slap that like whatever in my desktop. I don't care if it's untitled. That's totally fine. There we go. I want to know where that is. Is that genuinely a thing? Google. Yeah. Okay. Cool. Search by image. Let's upload that image. That was on my desktop. That's LG. Oh, it's literally it's the logo or thing for Kaspersky. I see. Kind of neat. That's kind of fun. So you can probably tell, like, hey, I'm kind of riding this train that this might not actually be Kaspersky. It's a facade. It's a decoy. It's deception. Let's take a look at what that update.exe is first before we dive into our little Kaspersky spooky thing. But that update one is seemingly very small. So if I ls, right, again, there's not a lot in there. Oh, that's
You use like
update.exe? Is that I didn't even know the right thing.
You guys should let me know. All right, let's remove
that whole update.
I didn't touch it.
We also don't have that
You don't have legs.
We
Did you
will
look behind the
download that
board?
one more
I
time
think I
and
saw it
actually
there.
get the correct file there.
Yes.
Grab the update.
Now that you mention it,
I was like, why is the size the exact same size of both files? No. This update is much smaller. So let's crack that open, shall we? I have my else file opened up here, and let's go ahead and open on my desktop that update.exe. You can see that has a different icon because it's a different binary. Gotcha. All right. So this is using some reflection libraries, interop services, so stuff that might be able to do some peculiar things. Let's open it up and explore some of those other libraries and things it might include. Nothing seemingly in metadata. I guess that's just kind of like the library headers and everything in the file itself. Resources, do you have anything in here? Not displayed for me. Let's go to updates and update properties. Resources. That doesn't look like it's all that interesting code. Let's go into update 4. Right, let's see what this thing does. I guess I can expand all these, and we just initialize the component. So this is a graphical interface, right? We could run this to actually probably get a window to pop up, and I might do that once we're done kind of looking around and analyzing this thing. It is a GUI. So dispose, remove it. Those are, I think, boilerplate stuff for when you end up having a like Windows forms, and it just sets it. Okay, so the program is probably where the fun stuff actually happens. So what we do, check for some arguments here, and the argument that is supplied, is that arg0 going to be the program itself? In process by ID, in resource args, or is that going to be like what it supplies? It's kind of odd. It doesn't do anything other than that try, though. That catch doesn't do anything. I might be misinterpreting that. But we get the path being supplied as the other argument, and text being supplied as the other argument. So we look for files with a string path that is apparently just going to be passed into text, and the extensions that will be supplied are exe and dlo. So for each of those items that we find, each of those files, we delete them So both of these we end up going through, right? The list files, we get everything that's supplied in the other argument, all EXEs or DLLs, and then we combine them. Oh, sorry, bring me back. Destination file name will be path combine that original text that we deleted with an EXE. If it is an EXE, then we save that in what would have been path 2. And then we try to copy it over there. Okay. And we run process start on that process start info, which is now going to be that new thing. So that doesn't like actually update all that much. It's not like it's pulling down from the internet or anything. It's grabbing whatever files might be in the current directory. So if for whatever reason we got another DLL, if we got another EXE, maybe that was doing something to pull it in. This is just a definition for that get files function that we were seemingly just calling earlier. We just grab that list information and grab it in extensions, right? Okay. So they're actually using the real get files there now, seemingly. And checking if the extension matches and returning them. Okay. So I don't think this does a whole lot else, honestly. Let's kind of stop the system IO thing from expanding because that is taking up a lot of space. But that update just seems to, for the program, do these things with EXE files, like copy and delete them. Let's try and run it, you know, just to have some fun here. I'm gonna copy this Kaspersky.exe. I guess I can just download it from the other computer, right, if I need to again. But just to be like safe, let's disconnect from the internet. Not that like it's actually doing anything. Let's just disable this. Okay, and let's try and run that update. Even though we kind of looked through it and saw that it might just do some weird stuff with that other EXE. Did anything happen? Did literally anything. I'm clicking on it a lot, but we could probably take a look at like sysmon or like systerms or anything that can process, examine that or see, make sure it's actually running, but how about if I like made another, I mean, are these all going to be in the same directory, right? Working directory, oh, it needs the arguments, duh. So, we need to supply text. We're looking for the path. So let's simulate what this looked like to begin with. I'll go into C. Let's make, I mean, we already have a Windows directory. And I am in a virtual machine, right? So I can just kind of blow this thing up, and for whatever reason it gets messy. Let's make a little Kaspersky directory, and you won't let me because I'm not an admin. I don't care. I will start up Windows Terminal as an admin. Let me do what I want. Am I actually an admin now? Just actually tell me. Let's try to make that directory again. Yeah, alright, cool, we did it. So let's copy everything from my desktop, all of those exe files, let's put them right in this Kaspersky directory. And now let's, do I have the touching there? I do not. Silly PowerShell. Let's just echo nonsense into like a fake .exe because it's just seemingly checking for the file extensions. And I lost myself in PowerShell command. Okay, so let's try and update the fake that is in C Windows Kaspersky. Am I understanding that right? I don't know. Path should be seemingly the third argument. Text should be what I've supplied as the file. Do I need to include the exe exe extension in here for some reason? No? Am I going down a rabbit hole? Honestly, this isn't obviously where the spooky stuff is going on, so we can table this. I think we've had our fun bumping around this update, but it doesn't exactly do much other than copy files. And I might be kind of getting in the weeds here and not exactly following what is happening because I'm done. So let's go do something else. Let's remove this update and let's try and add in. Yeah, we already interviewed it, so I'm not concerned about that. Let's just pull in that Kaspersky.exe and let's see what we got, ladies and gentlemen. Skryim.exe 1.0.0.0.0. The assembly title is B. Assembly product is B. Copyright 2015. Yeah. Okay. So metadata we know won't be anything else interesting. The references that it pulls in, however, are I think peculiar, right? So you saw those DLLs in my Linux folder over here. If I hop back to that, you might have seen a net.dll. You might have seen a HiLabo or HateLabo, a Newtonsoft JSON.dll, S22. So let me kind of Google what these things are, in case you might not be familiar with them. Because I wasn't, truth be told, right? The Newtonsoft JSON.net is a high-performance JSON framework for .NET. So it is going to be allowing us to use JSON inside of the code that we end up running, serializing it, working with it, deserializing it, etc., etc. So that we might see put to use. And the other one was HateLabo converter. Let's Google that guy and see what this thing does. Or what is just HateLabo on its own? Because I just pulled in just that converter, but there was like a core, there was like other fragments of the library, but it provides mail client features for SMTP, POP3, and IMAP. So our little Kaspersky program might be sending some emails. Is that fair to say? We got JSON, we got mail functionality. What is this Sassel? What is this Sassel.dll? Let's grab him and see what he's up to. This supports authentication methods. So, yeah. This repository contains a .NET assembly implementing the authentication and security layer for the Sassel framework. Provides a protocol or specifies a protocol for authentication and optional establishment of security layer between client and server applications used by internet protocols such as IMAP, POP3, SMTP. I see. So a little bit more nod to emails in SMTP, right? Okay. Well, let's stop beating around the bush here. Let's go explore what this fun little Kaspersky.exe might be doing. Now we've got an idea as to what these other references that were included are. Actually, I'm curious still about that net one, but we can explore that in just a moment. Let's check it out. This does have seemingly some resources. Again, theoretically, it is supposed to be a GUI thing, so we can see what it exactly does. I don't know if you can see right here. I don't know if that's visible or not, but this is seemingly a namespace or a class kind of named SMTP Sender. So it has some enumerations here. We have connect status, it looks like, with values set for none, connect, and error. Load config file results, succeed, file not found, format error, and main form. Main form is a little bit hefty. There's a little bit more of that scroll bar there. So we have that default IP.txt file that we had seen. And checking out these references right, of course, we see HateLabo, if I'm pronouncing that right, and the SMTP Sender class itself, right? So, or the whole thing. I think namespace is the product. I might be wrong in the term that I threw out as I'm just kind of rolling off the cuff here, but create a main form, create an SMTP config, which looks like it's something that's defined over here. Cancellation token source, That is not defined elsewhere that I know of, seemingly. Last 60 cent count? Last 60 cent timestamp, IP list, send mail tax. I'm assuming that should be task. Maybe a list of tasks. IP list count, str IP list file name, current IP index, etc., etc., etc. So we're saving some IP addresses in this default IP.txt file. Take that for what you will. Let's hop on over back to our Linux machine here, and in that related directory, I do have a default IP.txt. So let's just take a gander. Let's take a look at what that might actually include here. I'll run cat and pipe that to less. Just a big long list of IP addresses, everybody. So I'm kind of curious what if there's a lot. I don't think I actually have some live text installed in this VM yet. So how many of them are there? let's pipe that to WC TACL. Let's get the word count lines. Oh, 73,312. Of course. Don't you need that many IP addresses for your antivirus program? I don't know. Let's cat that out one last time, and let's see where these IP addresses just like. Is there like a cheeky IP locator thing or IP location finder? Yeah, where's my IP address? I don't want you to tell me for myself, actually. I don't need that. I do want to put it over here. Taiwan. I don't know how well you can see that. Does that have a domain? Hangit.com.tw is Taiwan. Let's go to it. Let's just do it. I mean, it's a thing. Okay. Let's check out this guy. How about you? Are you also in Taiwan? Ta-da! Nope. Israel. Okay. What about you? 72.52.170.252. Slap that in. Oh, that's over in, what was that, Canada? United States? It didn't tell me. No, it didn't. Where's the state that you were just showing me that I accidentally clicked out of? Wichita. Or somewhere close to it. That. Okay. We could go down this rabbit hole for a while. Obviously, I'm not going to go through all 73,000. Maybe we can write something that would loop through it if we wanted to, but these are all over. We've got Brazil, we have Israel, we have Taiwan, we have Kansas, the United States. What else we got here? Miami? Cool. Alright, just one more and let's get back to something more fun. It's over in Argentina. Let's take a vacay, guys. Yeah, alright. That's enough spooking around the internet. But as you can see, there are a lot of IP addresses, and maybe we could write something fun and funky to seal those locations. Let's do that in a different video, because that's not what we're doing in this one. Let's get back to our little Kaspersky.exe, so to speak. Let's check out SMTP mode count, SMTP string header text, string body. So just based off of these variable names, I'm assuming like all the references and the kind of the loaded in libraries that we've seen, and SMTP robot, I'm going to assume this thing is going to end up sending emails, right? Kind of somehow, some way, at some point. So what else we got? Here's the main form, and that is another form here, initialize component. We should run this thing. we should see what this thing does. Get total memory in bytes. Okay, do a little reconnaissance, computer info. And that is an actual class. That's like a Microsoft thing. That is loaded in, right? Microsoft Visual Basic. Yeah, devices, it grabs that. Hey, how much memory do we have? What's my device info? Boy, that uses some WMI. CPU info, memory info, pulls it in for each management base object in management object searcher, and that looks like a WMI query for Windows management instrumentation. That's some of the thing. Hey, let's grab in whatever. parses out a number of logical processors. Here, let's get CPU info, memory info, etc. Nito Benito. Get instance is going to return itself in the main form, seemingly. Load config comes in from config data, which is passed in, and looks like we load from Skryim. That config was defined as a new SMTP config, so that might be something we could actually kind of follow through. Get count from file. Oh goodness, what the heck? We have a file stream object, read in with a file name. Number, buffer size, read access, random access, seemingly. That just looks like it's counting the number of entries in a file, I think, maybe? Let's get the IP list from a file. Okay, that looks like the exact same thing. It looks like it's doing the exact same thing, just counting. Start send mail task. Now we get to the weird stuff, right? Sendmail tags.clear with threads, adding new tasks to send with a robot, our robot status, our SMTP robot. We got a completed function that just checks, hey, whether that robot status is stopped with 3 Ps or not. Same thing with the stop function, and then won't be reading. So is it like going through each of the IP addresses and trying to send stuff? Like every single one of those servers or something was, I don't know if that would be like the mail server itself, or I mean maybe. Like when we looked at that one in Taiwan, and the HTTP had a domain to it, but I don't want to like obviously run a mass scan on something like that. But maybe that has working open or anything for SMTP or IMAP or POP3. Spooky. We got log thread. Wait a second. Are those in the logs? It has strings like, oh, mail send, okay. And an authentication error? Authenticate error? Good. After first. Oh, and it writes it to SMTP log.txt. As if we have that? It does explain thread. Oh, it literally logs like everything does. The IP address, the port that it calls out to, the SMTP server, password. What? And the subject. That is neat. Also horrific, but neat. We don't have SMTP. No! Do we have log? What is that log context? I don't know what those are. But we didn't have an SMTP log. Okay, is that a dead end? Log good SMTP. Get use offload. HTTP client, does it like check it? Oh. Does it like check to see if the server is up by like the HTTP thing? So that Taiwan one with maybe it was up? I don't know. I'm not gonna pretend that I know. I'm gonna keep cruising though, because we got a lot to go through. Send mail thread for test. Weird pull one server. What is that? Oh, that's later down. Let's. Is that later down? Where am I? Yeah. Okay, that's later down. So let's wait till we get to that. But it will sleep, determine if we need to wait, and create a new SMTP client with the IP address, the port, the password. Generate a message. Set encrypted communication. Try to connect. Connection paired, etc., etc. Mail sent okay. Mail not sent. Okay, I think it's fair to say, guys, that this is not Kaspersky. I think it's fair to say that this is not the Kaspersky antivirus at this point. If you've got classes named SMTP sender and all that weird stuff, completed thread, get replace string, get random. Ooh. It's like replacing the segments that it would be using in an email. Subject from, recipient, mail from, and just that's neat. And then it applies random on each of those things. We have generate random and we have apply random as other functions here we can take a look at. Oh, and we we have a little like schema as to like what we want to replace the random with. So get characters from this range, get characters from that range. That's neat. Apply random does, I think it's a similar thing, right? Yeah, okay, so it's just checking if that rand notation is in there and then generating it as needed. Spooky. Populate number doesn't seem all that interesting. Populate a number, construct the header and body of the email, I'm assuming. Yeah, content type, you get some headers in there. You add in the body. Generate message. Okay, SMTP message, is that something that's defined in here? I don't think so. But SMTP mode, recipient, SMTP server are all added in, and we add in the text. We grab the email addresses sent from and sent to, all from SMTP message. And all these configs come from that. You can send either HTML or plain text. And we have a load IP address list from file, taking account, load next IP list file. Ooh, that has a new file name in it. Oh, so the log status is being added into log.txt. And we have log.txt. But I don't see those hyphens in there or anything that's an IP address. There's nothing in it. But tempgoodserver.dat might be kind of neat. What do we have in that? Do we have temp good servers? Oh, we do! Are those just the good servers that it found? Is that the same as our Taiwan guy? Was that? Let me bring back those pages. That was Ukraine. mx.uhorizon.com. MX indicates mail for me. Okay, so those are some of the good servers that we were able to send emails to, from, or through. Spooky. What else we got? Pull one server we saw earlier. That looks like it's just grabbing things and getting out of the config, the SMTP accounts, etc., etc. Refresh time variable. How much more do we have to look through on this one? We should probably move on to something that might have a little bit more spice to it. But I think we can, at this point, come to the conclusion, right, that this is sending emails. And if they are mail tasks, I wonder if this is a, like, command and control framework. I wonder if this is some, like, RAT might not be the right word, not our remote access thing. But part of me wonders, okay, is this being used to send, like, command and control or to actually be able to interact with this victim that this Kaspersky.exe, supposedly, our fake antivirus is on? But yeah, load good servers comes from tempgoodservers.net, so we know that those are a thing. Let me see if those other ones. I'm sorry, I'm going on a tangent. That was kind of neat and interesting. Let's check out our other one. Where's he at? Indonesia. Got an 89 here. There's a lot of good servers in this. Out of the list of 73,000 that we just saw, that is over in Italy. And we could poke through some of these if we wanted, but each of them seemingly have had a domain name associated with them. Nope. Did the other one? That second one have one? I just want to check one more time, because the first one I know did. This one did. Yeah. They all have domains. And they're all related to a mail domain, or at least kind of indicated. Okay. We got our few proud over here. We got our temporary good servers, and let's get back to items. Let's get back to fun stuff. But we know those are the good servers, and we can log in some of that. Good server index, load previous status. But the previous log.txt and see what of these makes sense if they do. So we know that that was all of this as we read lines. So let's copy that. Can I copy in and out of my... Try it? No, I can't. Dang it. Alright, let's make this minimalist. And now let's expand that window. We gotta see what we got here. So, current IP index is 41,972. That makes sense. Current pass index, 122. Done IP count, excuse me, STR. Current IP list file name? Is this hash? Is that a hash? That looks like a hash. Next IP list file name, deposited time, send mail counter, done try count, total try count, good IP count. Yep, that makes sense. And the int IP list is exactly what we saw when we counted all those. Whoa. Okay. That was kind of neat to tie those together. Go to current position of the file. That must be taking everything that we had seen thus far and skipping over to that part. On start invoke, on stop invoke. We begin invoking some delegates. Action. Okay, that is from the runtime stuff. So that I might not know. On stop and on start though are called in each of those. So the robot, if it is started, then it doesn't need to start anymore. Then it... What? No, but if it doesn't need to continue... Oh, stop, please. No! Where did I go? Go! Oh, it's the very, very top of the document again. Okay, sorry. We'll get back to it. We are trying to figure out what this on start window is. It'll delete the next IP address list, load default config from the default IP addresses, good, download IP, I don't know what exactly that might be, but did load default config, so is that something we already saw? Temp good servers, log.txt, it clears them out. Then we get the number of IP addresses, how many we need to go through, go to current position file, and load the good servers. So we delete those that aren't necessary, seemingly, set up some threads, see how long we're going to end up waiting, I think. Like, give it a little bit of time to not look so spooky, not look so sketchy. And whenever the timer goes off, it does some other task. On stop, okay, yeah, it stops it all. Reset robot status. On set config. Default CFG. Ooh, that's a new one. What is that file going to end up being used for? On set config, robot status is started. We get a binary writer. And we write the config data, which is passed in as an argument. But that's a byte string. What is in that? What is in that default.cfg? That's called again on get config when we read the data out. Binary reader, we read that data in. Sorry, I realized my face was kind of in the way. Base string length, we read it, and then we do send config on our SMTP robot. So we should totally check out that SMTP robot. We do check all the URLs or the IP addresses. Once we're connected on a master, then we start a monitoring loop. Okay. Master disconnected, server IP port. What is that? HTTP client response message. Retrieve that server URL. Make sure that we have a successful status code. I'm going to go to that just real quick just to see what it looks like. Yep. Looks like it. Okay, it's just checking if it got like a 200 or something. And if we did, we get the results from that. And then we decrypt them with a string cipher with Shangway Forest, Foresight, 1988. What is that? Is that something that like is existing? Is that a thing? Let me go back to Google. I know I'm already on Google, but I'm on the image search one, and I don't have internet. Gosh darn. All right. Get me back to my adapter settings, please. Enable that. Go, go, go. We're getting intense here. All right. Let's see what this is. Let's go to Google.com. Please load. Cool. Slap in Shangway Foresight? No. There are no results. There aren't that many good ones. That's sad. What if I look for like malware? Is it like a known thing? Is that a totally random key or something? I don't even know what this is actually being used for yet. So like, let's table that for now, and let's go back to analyzing. That is passed into the decrypt method that is inside that string cipher input. We parse out the empty entries. They're separated and delineated by a colon. So we get a server IP address from port just like that. Yeah. Oh, what is that? So the servers that are passed in here, we retrieve. No. String server URLs can end up being different than that.
Hear my prayers on the Macintosh and grant peace.
We have some server that will return a list of other servers that will be used for. Oh wow! So it'll be used for that communication with SMTP, maybe.
Lord,
Master Connect thread is going to end up trying to get some of these things. We'll wait for 10 seconds to do that over and over again to see how many times we can get it, and then we keep reconnecting and checking. Okay, that's evil. That is nefarious. Load default config. We'll take in default config as that file. Oh yeah, we still need to look at that. Default IP address. Pull all that stuff in and check to see if the IP list ends with a slash or URL.txt. Oh, so in case there are like other directories, is that right? IP list URL file? I'm kind of cruising through this, so I might not actually have fully understand it. Ooh. Get public IP address is just gonna, get public IP address is checking itself. Come back.
I pray that you
It's just going to check IP.dimDNS.org. That's a thing though, isn't it? Will that give you the real IP address? I'm gonna have to blur this out so we show my IP address. Yeah. Confirmed, it does give you your IP address. Your public IP address. Neato. Okay. And we're almost done. We're at the very, very end of this, of SMTP main. Connect.dat is pulled in. And again, it's using this Shangway Foresight 1988-227 to decrypt it. So we gotta check for that. And please make sure it's a valid connect.dat file. Will this thing die if I try and run it? Because I don't have that file in this machine. And then timer set log tick. You can't see that face in the way. Can I just move the screen? I'm very sorry. It just pulls in from log and temperature server just because dispose and initialize components are going to be what we've seen before. Get that screen back to where it should be. And let's go explore that default config file. Because we have that.
Hear now the prayers of your humble servant.
There we go.
Bless these departed souls.
We don't need to be here anymore. Let's see. We do have default config. So let's cat that out. Default CFG. Is that just a bunch of base 64? is that just base 64? There's a lot. There's a lot in here, guys. How long is this file? Let's WC tag all that. 5,337. Okie dokie. Let's do like file read line. So we can echo out that line. I'm pretty sure you can do this with XOR just as well, right? makes sense, though, right? Because this default config file was decrypted, supposedly. So, let's see what else we got. Net data. What is net data? This is another class that I'm looking through in this SFTP sender namespace. These just look like they send packets. That makes sense, considering... What? Excuse me? Let's see what that thing is, shall we?
Here's how.
Oh yeah? So that right in their signature does not match the Korean language detective. Okay. I'm not one for like hate attribution. I don't care about this stuff. I'm not one for like pointing fingers. It was him. He stole my lunch money. I'm inviting him to my birthday party. I don't do that around here. It is kind of neat though to at least see the traces. To at least kind of walk through all of these. Every single one of these is. The number of pieces of material you were trying to cut is not correct. What does that mean? Oh, it's trying to get a certain number of things. All of these exceptions. I'm just trying to understand them though. I just kind of want to know like what's what here. There is no data. Yep. This is kind of homegrown. Like they're adding in their own exceptions. Like they wrote this on their own. Slap that in. Same thing with pop. Has the same exact output. Are there any other exceptions that might be interesting Korean strains here? This looks spooky wooky. Slap that in. The data type is incorrect. Must be byte array. Alright, so they're leaving some notes for themselves, buddy. Net data event, that looks like a delegate. Is that something that's like, is that like one of those tasks that's being pulled in? Net message code, parse item enum, parse random enum. Oh god, the program. Oh, this is kind of neat. This is like what's going to end up calling, right? So it's going to check if .NET is installed. It has functions for that. Get check the registry to see, hey, do we have v4 seemingly or not of .NET? And maybe I'm going too quick on that. Yeah, it checks. Okay, if .NET is installed, it's not even installed to run this program. Starts a robot status with a little scanner time starting right now. Enable visual styles and show if there are errors. Okay. Robot status has just a lot of stuff defined. Time span is get up time. Whoa. Just trying to see how long, hey, how long has this robot been alive for? How long has the C2 been active? Connection status, a couple of errors and centers. S6P robot, we're on server connect right now. So server connect will connect with seemingly a socket. Connect will connect to server. On connect, we'll try, and if we do get a connected connection, we'll get the main instance and explain that we have connected with the on-net. We'll call that on receive. On receive. Does that do anything spooky? No, I can't click it. Analyze packet is going to end up invoking something from the net data, and our net data did do something. Type code aggregator link. Net message code. What is this? So these are the control codes seemingly to do a certain thing, but it's just sending logs and sending the data to nodes. Update status, control server. Did we ever see that? 1040 control server. Telling it that save config, against config, starting communication. Totally C2, but I don't see it do anything to like run code. I don't see it doing anything like run commands. something. And that data event. Okay. Let's get to our server status. Right. So it's just another enum. SMTP account. We do parse from. SMTP account is parse from with an ID and a password. And they're just pulling out again the colon separation. Two-string, obviously two-string. SMTP config. Alright, we knew we were looking at some weird stuff for this because this is in relation to that vault.cfg. So what do we got here? Tungsten string config password is that Shanghai, I don't know, Foresight, that thing. Must continue auto threads, str receipt. A lot in here. SMTP config. Reset. And call it reset. And string config file name is default.cfg. SMTP port 425. We have the timeout set up. We're trying to keep track of the headers of the accounts. And that's that. So, the screen reader is reading from the data, and it looks like this is like breadcrumbs of what that config file might actually look like. We have headers defined here, SMTP accounts, and the ending tags for them. So it has its own like structure and schema how to understand that config file. And this just looks like the function to parse all that data out. Cool. Wow, we get the auto threads, and just from this thread connections, IP list file, all of it is included in that default config file. Okay. So load config file result. Encrypt write line. So the string cipher can encrypt that line with that's passed in this function with the again exact same key. Same thing with decrypt line. You save the file, spit it all, general recipient. Okay, so this is what it would look like. But all this data is going to end up being pulled from that master server or whatever that we end up reaching out to with our Kaspersky guys, right? So SMTP robot has encryption key. SMTP mode was just another enum, so I didn't want to explore through that. But SMTP robot does seemingly do stuff, and that is probably like the agent for the bot, right? That's going to be the task grouping when it's, I'm assuming, doing the nefarious means. You're performing the C2. Get first IP address list. SMTP robot adds all these codes. Prog get log. Yep. Get it since it loads it. Send data connect server do start call. We have our good servers pulled in. Send data must be for message codes. Connect the server. We saw. We understand that basic functionality. The monitoring loop, though, the monitoring loop, every 5 seconds, tries to connect and send data. Do start comm, just starts communication and sends it. Yeah. Just sends the hey, we're talking now, having a conversation. Hello. Send data and heartbeat. These are all the net message codes that are kind of added in. Save. So this just looks like, honestly, it just looks like it's still in communication. It's still just talking back and forth, sharing the data and the information that we're receiving or getting. But I don't see anything that like runs commands. It's still smooth one way or the other. Okay, let's monitor your machine. Is that normal? Does Kaspersky do that? Do they send it across all these different worldwide IP addresses through mail, like through SMTP? Alright, SMTP server pulls in the Pig Lambo stuff so it can get encryption. SMTP server pulls in that encryption module, parse in data from the config scene. So we think, yeah, you can pull it passed in. And two-string again. before I dive into this, let me just check out SMT Sender. Doesn't look like there's anything that interesting here. So as the string cipher is where we're going to focus right now. So we know that default.tfg, or that default config file, is encrypted with what looked like base64, right, when we took a look at it, but it's encrypted supposedly with this string cipher class functionality, passing in that Shanghai Shangwei thing. So we have this initialization vector also visible for us with the bytes here, some random ASCII letters, and we have the functionality to encrypt and decrypt, which is cool because we have the data that was encrypted, we have the decrypt and encrypt function, and we have all the keys that were used to encrypt it and decrypt. So we could just try and decrypt all the data. Yeah. Let's try it. So, I would do this because this isn't C#, right? Normally what you could end up doing is just compiling your own code, right? You can do that on Linux if you want to, in Xbuild or Mono or etc. Or you can just plop it into Visual Studio if you're running Windows, but that's very large and very clunky. I would think I would go through this and try and do it in LinkPad or LINQPad, and that it makes it sort of like C# feels like an interpreter or an interpretive language, like a scripting language. Like, hey, you can just slap code in and compile it and run it like on the fly. I'm sure it's doing more cool nerdy bells and whistles things on the hood, but that feels cool. So I have a LinkPad installed. LinkPad. All right, cool. So I will make this and I'm pretty sure, like, hey, let me type in some words here. Hey, hello, please subscribe. Sweet. I want to make that larger so you can see. Preferences.
Lord
Yep.
of season.
And I can make it dark mode. So much better. Show lineup is better. Yep. Let's do word wrap. Can I expand the font size, please? Hello? To change font size, oh no, sorry, use control scroll wheel. I didn't mean to do any of that. Can we go back to my default? I like that better. Zooming in. Alright, cool. Now we're up in action. Let's get to some cool stuff here. There is a way to just kind of like run a program though. C# program? Oh, sweet. And it just will do it. So let's do a console write line with a little proof of concept. Please set.
Welcome them
Cool.
to the realm.
Yeah, do you want to save that? Let's just slap it into my desktop. Decryption. Decrypt shop. We added the B in the end. Okay, it just says please set. So now let's get the functionality to encrypt and decrypt with all of this.
Here,
We need all of these using statements.
and grant peace.
And let's build out this functionality in this string cipher class here. So I'll slap all that in, and yet let's move the using directives into whatever they need to handle it. And we're still missing something.
Lord of
Password
season.
derive bytes.
You might want
Where did all this
to.
new password? Oh, is it using a different like C# syntax? Rather than using the using statement, can I just define them like that? Yeah? Okay. Okay.
I pray that you will shepherd
Then
these
let's
souls
do all those.
as into the realm.
And now we've got that functionality, now we've got that code inside of the string cipher class. And back in the main function, I will, how do they do that? They use the string cipher decrypt. We you saw that in name, right? String cipher, decrypt, something. Passing in this, right? Yeah. So let's grab one of those encrypted strings and see if we can get it to decrypt. I think that's all we need, right? Let's just hand out default.cfg. So this right here, can I please paste this in? Please? No? Okay. I'm pretty sure I'm going to need some line text so that I can do some quick multi-line editing stuff. So let me just download that super duper quickly. And in the meantime, we will download the... Good. Let's download... What am I thinking? Oh, I'm so sorry. I need to download the default config that we have up on the server. So that laptop that's beside me is hosting the related files still. In related, I should be able to grab CFG. Of course, I need that stupid basic parsing. And now let's outfile that to default.cfg. Yep. Okay. How's line text? It's going good? It's all good? Okay. I probably should use like Chalk.me or something to install that. But you know what? You live and learn. Like that's bad Sonic the Hedgehog song. If you know what I'm talking about. Maybe that joke wasn't all. Anyway, let's actually open up Explorer like in this directory so we can actually open this Sublime text. Open with more apps. Sublime text .exe. Good. Okay. Here are all of the encrypted lines on our Windows analysis team. So we can fire up LinkPad and try and decrypt this. And let's display it out onto the screen. Console.write line. That. And let's run. General. Okay, looks like we did it there. Because I think from what we remember, looking through this, that should have been the very first line explaining all the definitions here. So if I did something horrific and wrote on every single line here, let's do a console.write line with our string cipher dot decrypt, passing in that data. Let's go all the way to the end. And then let's include that Schwenk Foresight password or key here. Slap that in on every line. Close that line and copy it. Are you sure I couldn't have afford it? But then I'd have to know C# and I'm bad at everything. Oh, it is all currently string cipher, not string cipher. That would have been messy. So let's try and get that string cipher. There we go. Now everything should be decrypting with that key, and I can disgustingly slap all of that. We'll write it all out. So let's see what we got. Right. Oh gosh. Why did you die? What happened?
Grant peace to these departed.
Oh, I forgot. No, I forgot a parenthesis. You know, this is when you guys are going to be like, Elgon, writing the stupid stinking for loop would have been a lot easier. And I'm like, you're right, you know.
Lord of seasons,
Alright, let's Control Z that out of there. Slap that all in successfully. now. Fingers crossed. And let's try and run that one more time. Why? Alright, one more line of range. Oh no. Wait, where's my string cycle? Why is that still a problem? You know what? We should take this. Take this from the top. I screwed it up so bad that it wasn't worthwhile. So... Why is that left there? Yeah, that line 27 and some of the lines are like jank. Let's control Z all the way home. There we go. Okay. Now again, console.writeLine. Sublime text is like chugging along, trying to keep up. String cipher dot decrypt all the way to the very end of the line. And we want to copy our Shanghai force. This will all be worth it in the end, guys. I promise, hopefully we'll get something cool out of this. Okay, Flores, close those. And now, third time's a charm, everybody. That doesn't look broken. Unless I messed it up somewhere else. Let's give it a go now. Pretty sure I just copied that to the hope. Nope. Okay, let's try it. Ray, please. Padding is invalid. Get off your foot. Excuse me? What are you talking about? You just encrypted. You literally just did this. What? F5. I am so confused. You just did this. Is it the right line? No. Why did these all have a Z in front of them? Every single one of them has a Z. Did I hit Control C? No. No. Agony. We're almost done, ladies and gentlemen. I promise. I promise. Console.writeLine. For the fourth time. String cipher dot decrypt. That. Take me all the way to the end of the line. Sorry for sticking to my guns. I know. Everyone is screaming, John, write a secret form, have it read a file on its own. Look, dude, sometimes a man's gotta do what a man's gotta do. In this case, publicly embarrass himself on the internet for thousands. I think we're good. Famous last words, because I've said that thing before. Please God, run. Nice. All right, what do we got? Let's slap this into Sublime text so it's a little bit easier to read. And I probably shouldn't overlay. What are we looking at? What the heck is this? All right. The general tab is not setting continue or auto thread as recipient to cookie.nick2017@outlook.com. From SMTP, it looks like he's going to end up using those random things. Nice. At superuser.com. Oh, sure. You and your Stack Overflow, Stack Exchange, superuser things. Oh, now we have threads. Connection timeout, read timeout, group header. Config name. 2017 Type 1. IP list file name, IP URL is http:/new5waves.com/IP. IP list URL file, Inc. Is that a thing? Does that exist? Does this machine have internet now? I think it does. I'm on a virtual machine. Once again, famous last words. Alright, so /IP doesn't get us anywhere, but this Inc. 29, that looks like it's IP list URL file. Does that need to be included? Should there be like a .text or something? .cfg, .log? This is a cPanel server. So, you know, book config URL is empty. What is that? Something died with encryption. Config, contact type lane, subject, server, body server. Again, super user port 25, log good file, name is empty. Just a lot of settings, right? So headers from recipient, subject, easy, SMTP accounts. What is that? Philip, password. These are the usernames and passwords it's using to log into all of the SMTP servers. Is that right? I think? Look at this. There are so many of them. Look at this scroll bar. There's so many of them. Oh, that's so crazy. Yeah, 5,336. Just stupid username. Oh, that's why there was that count in the log.txt as to which password you were on, because you're gonna try all of these fake accounts to see what you can get an authentication with. Oh wow, that's cool. That's crazy. That was fun. I like doing that little decryption because I mean we had the key, we had the initialization vector. That was everything we would need. Oh wow. Can I set this to like an INI file or something? Or like a bash script? Yeah, that's somewhat beatable in a disgusting way. No, it's just like got some god candy colors. But the strings look funny. The variables are set. What is this? Some username or user pass setup. Okay, so that must be like how it's going to be connected. Okay, I almost forgot to try and run the malware because that would be kind of fun. So let's do that. I will minimize this context window and I'll make sure I actually don't have internet connection for real now, because I don't want that to legitimately affect my VM if it's something spooky. So change network adapters and disable that guy. Cool. The other thing I want to do is actually look at that net.dll also. I don't think I had that one downloaded just yet. So that, I want to go back to my users. John H. Okay, and we put it in the desktop. Let's also, do I have a wget? Can I control R? Wget? Yeah. Alright, so let's get that net.dll and also save that to explore that in IELTS. Net.dll? That's fine. No. Oh. I just turned on there. I'm stupid. Let's turn that back on just to download that then. I should have like put that together, you know, I should have kind of mentally knew that was gonna happen. Now I need to remember to actually turn that off when I want to run this malware next. But let's check out this DLL, just to kind of see what it does, because it looks also weird. Client sock, KS, seemingly. References it includes nothing new. KSIT.net. Is that a thing? Can I Google that? Does that have like an understanding of the world? Is that an actual thing? No. Go to Google. Google that, not
Dumper tenancy URL. No. Seemingly, network application. No. I don't think I'll be able to find any based on that. But determines it is inc. Okay, has an decryption key, receive, disconnect. So I'm assuming this is just going to end up being for how it. And these are the client sock functions that we saw earlier. But begin receive and on receive. Client socket has error messages that are there. Ooh, and we have new Korean language to look at. Let's go to Google Translate. Take a look back at receive data on receive. It has hash codes seemingly in here. Receive formats are correct. Identification code, and there's a hash code, and then some bytes that might be included. Receiving target byte. Inbox. Okay, so that has to be like some mail, obviously, we're seeing here. The else probably has very similar identification code. That hash, is that hash code something for the instance? Yeah, because it does converter.get instance. We have converter down here and a server sock. So on receive, no, that still bears out. That is a long message, longer message than usual, I think. No, just a number of bytes and their own encryption. More logging. I'm curious if any of these, it's all going to end up being the same stuff, though. Send data, on send, and close. Okay, log the file. Ooh, puts it in a socket log. I don't think we ever saw those. Like a directory with a socket underscore log file. It just copies it all in. It also has date here. It has messages, delta leave log file. Huh. Okay. What does our converter do? Is that going to end up actually doing anything peculiar or just converting bytes? Looks like it's just a bunch of functionality, overloading functions for the get bytes function with different parameters being passed in. So, yeah, it looks like it's just trying to understand and interpret that data. UN64. Oh, there's decrypt and decrypt, though. And that is just XOR. It's literally just XOR. Technically. Are those defined anywhere? Encoding format, process packet, not included server sock. That looks like kind of the same stuff that we just seen, except for well, the key is 1, 2, 3, 4. Nice. Yep. IP address parsing, connecting to the server via socket, receiving, sending data back. Okay, that's really all there is to it. Of course, we could have expected that's going to be doing like net connection stuff. Great. Let's see if our little fake antivirus program actually does anything. So let's turn off internet for like the 4th time. And this will probably whine that I don't have that default config file set if it actually runs it all. Here we go. Double clicking on our fake antivirus, Kaspersky.exe. If I have the default.cfd, does it do anything? Still no. Is it running in the background? No. Any details that has it. Is Kaspersky doing anything? I don't see it. So something must still be wrong. I can download all the files and see what it might board. I think that is okay
Take
to
home
call it
minus
quits
the
here.
precious produce
Maybe we
today.
needed all the other ones. Fine. You convinced me. Let's see if we can download everything and see what happens. Just to go through it all. That's listening on 48,000 for my local. Okay, so we have all the related stuff. Let's download. This file can harm your computer. The default CMG. Chrome tried to stop. That's kind of neat. Yeah, let's save that. Let's get that DLL. Let's see if Defender actually triggers on the stuff. Oh. Log.txt didn't get saved.
Oh,
Save it.
what happened?
Keep it anyway. Give me all the DLLs. Oh, I actually still don't have all the other ones that I didn't pull in. Maybe it just won't work. Maybe it just straight up won't work. Let's do it for the lulz. Let's do it for the internet memes. Let's do it for the YouTube algorithm gods. Let's just do it. So I put that all in my downloads. Yeah, okay. Alright. Good luck, Spursky. Do it. Oh, we didn't turn off internet. Don't do it just yet, actually. I was just kidding. I was jumping the gun on that one. Turn off that. Okay. Internet is no longer a thing. Kaspersky, you may now infect my... Wait, did I click on don't run? It's in downloads. Holy crap. Click. Run. We could like kick it over to some like Joe's Sandbox or anything, or throw it in Virus Total and see whatever weirdness comes from it. But I don't see it starting right. It's probably because it's missing those DLLs. That's fine. That's fine. We'll move on. We'll enable that one more time. Let's just kick it to Virus Total and see if it sees any neato bonito stuff. And then I'm calling it quits. Then I'm ending this video. So, Kaspersky, do it up. One engine detected. Viper. Trojan 132 generic. Cobra. What is that supposed to be? Am I infected? What do I do? Hi, I just ran a scan. I got this Cobra. Great damaging power to completely mess up the system. I need a simple malware analysis. Is there anything in the community section? Anonymous. Negative 32 voting details. Okay. Everything else is like, no, it's totally cool. I mean, look, maybe I don't know if that's really what it should be doing. Let's see what this guy thinks. Swolenator. Swolenator. Ooh. Huh. They didn't really do anything with it. Well, they thought it was a false positive. What does this thing think? This lob? A batch of spam email messages has been distributing a variant of this lob Trojan. Atticus to your computer. It sends pizza-themed emails. I don't know about that. What is this lob? I don't know. I don't know if that's it. I don't think it is. I don't think that is the right malware family. Not exactly positive.
So I think that's all the research or other post-mortem I kind of want to do. Looks like my VM is out of that Chrome, which just didn't want to play nice. But I think we can start to wrap it up. You know, we've done our analysis, we've done some fun stuff. I'll pivot back to the outro. Thanks, everybody. Appreciate it. But wow, look at all those username and passwords that are just set up for like dummy accounts. And it'll crawl out to all those different IP addresses, all 73,000 of them, find some good ones that we happen to see in all those different areas of the world, and send monitoring status or information via SMTP. I don't know if I can say it's command and control, right? I don't know if I can say it's C2 because I didn't see anything running commands or like running code on the victim or on this target. But that's not to say that there isn't anything like else that could be happening or anything else that's set up. And maybe I could be completely wrong. I could be completely totally wrong. Hopefully you guys saw going through this video, like, yeah, I'm cruising through IL Spy, I'll look through the DN Spy, I want to explore all these different files, see what I can make sense of. But look, I'm still learning too. So if there's anything that you can teach me, if there's anything that you can tell me, I'm all about it. I want to hear it. Please do put it in the comments. Please do help not only me learn, but help everyone learn. And that's what this is all about. So that was fun. I hope that was cool. I don't know how this stacks up in the other videos of the malware analysis stuff we've been doing, but I think using C# and using LIQPad or LinkPad to be able to decrypt that stuff that we see defined here, that's kind of neat and kind of cool. It took a little bit of finagling, took a couple of trips, me stumbling over and banging my head against the wall, but I hope it was fun. So thanks so much, everybody, for tuning into this video. I hope you enjoyed it. I hope you're enjoying all these others, and hopefully we can keep doing more of this because it seems to be really, really well received. It's helping the channel grow. And you know what else helps the channel grow? Is you engaging with the YouTube algorithm. So please do press that like button. Please leave a little comment. Please hit that subscribe button. Hit the bell. Smash, destroy, literally obliterate the bell. That actually helps keep you notified when I produce another video. All right, that's it. That's my outro. That's the whole thing. I had fun. I hope you did too. I love you, everybody. I'll see you in the next video. Take care. Some mod developers or a community and a hub that shares what should be clean and trusted mods, there's always the chance that the developer and something, some way along the supply chain could still be compromised. And that is part of the story that we'll talk about today. Because recently, just a little bit ago, and I'm behind on this, I'm a little late to the party, but look, on October 31st, Halloween, one member of my Discord server shares we have a malware incident in the City Skylines 2 modding community. Potentially thousands of game players affected, and there is an official post by the developers, including a virus total report of the suspected file or the malware and malicious part of this mod. If we actually take a look at the official post that was linked, that is over on the Paradox forum, and I gotta say, I don't play City Skylines 2, I don't use any of the mods, I've honestly never heard of this Paradox forum before, but it seems like this is where a lot of players get some stuff about the game, mods, things to get in the action, and that is a well-known, trusted, and reputable source. But there is an important update for all City Skyline 2 players. There's a potential security issue that has affected the traffic mod for City Skylines 2. Late Monday evening, an outside actor pushed an update to the mod, which includes a .dll file, or a dynamic link library, that they believe is malicious. We've already removed it, and the current version is still safe to download now. But if your mod was synced and you played the game using that mod between Monday and then there's a possibility you may have had the malicious file and have been compromised or affected. In this video, we'll do some reverse engineering and malware analysis to make sense as to what this mod from beginning to end, from cradle to grave, we'll talk about the original infection, hearing it from the mod developer themselves, and we'll understand the whole community response. And I gotta say, there's a whole lot to this story, especially with just how the community kind of came together. Because a lot of people have been talking about this. Eric Parker was digging into this, Low Level was chatting about this, people were screaming all over Reddit. I know the PC Security Channel and a whole lot of others were trying to track this thing. But if I may say, and I think this is awesome, I think the ground truth really came from JH Discord, which is pretty cool. Hey, Rem, my coworker, was tagging some other sweet, smart individuals. I do want to give the shout out to Loch Ness. Loch Ness Co. has done some incredible things with this, Illuminati Fish, and all the others that did get a chance to dig into this. And I know we had, like, the people from the City Skylines game modding community jump into the server, chatting, trying to understand, and it was really cool sort of synthesis of just normal game players and developers alongside, like, security researchers, reverse engineers, malware analysts, and there was just a really, really cool kind of, I don't know, showcase of the conversations and how that was going back and forth. And I know that I will ramble about that more later, but when we really get into this, Loch Ness over on November 1st said, okay, I'll dig into this now. And I know that Loch Ness is a big fan of Ninja, or binary Ninja, because when you're doing reverse engineering, malware analysis, you've got a lot of options, right? You could be using Ghidra, you could be using IDA, maybe R2, Radar 2, whoever you say it, Cutter and the graphical user interface. But I know, and even my great friends tell me, hey, Ninja, binary Ninja is pretty awesome. So we thought, look, let's follow along and do this just as well. We do have the sample over on Virus Total. Note that it has like 40 out of 72 detections across all these different engines now. And at the time of recording, it's November 10th. Granted, this was all kind of breaking ground on October 31st to November 1st. So there's been some time delta here, but at least it was uploaded to DT so we could download, or I could download it, I know, with Virus Total Enterprise, but not everyone can. So this was shared on Malshare, and I'm thankful for that. And I do want to give a huge shout out to Monkey and Raver from the PC Security Channel. They had shared the sample with my video editor, Nordgaren, and I do need to give an extreme amount of thank you and kudos to Nordgaren, because he, if you don't know, does a heck of a lot more binary and compiled language reverse engineering than I do. In fact, he's a game modder himself and super duper qualified to dig into this. So I got to learn a couple tricks from him as we got to download this fastmath.dll and rip it apart in binary Ninja. This is a real malware sample, so it should really be looked at inside of the virtual environment for safety and security, right? I'm creating just a Windows development box, and really you should have a snapshot ready and snapshot all the time as often as you can when you're putting this together. I'm just using VMware Workstation, but as this virtual machine starts up, we can go ahead and get in our disassembler and debugger. And before we go too much further, please let me say this video is sponsored by Flare. I'll tell you more about them soon, but just for a super quick crash course, Flare is a threat exposure management solution. That means that you can create different identifiers and even keep track of any activity out and about on the internet or even the dark web. So whenever someone is chatting about you, your company, your business, your employees, your people, anything that you might want to add different sort of detectors for, you can see that across even anything in illicit networks like marketplaces, forum posts, ransomware blogs or leak sites, Telegram channels, and all that shady dark web stuff, or just on the open internet like pastebin websites, leaky S3 buckets, GitHub, and more. And of course, there are a ton of data that they have available from ingested InfoStealer malware logs. This is where you can see any of the credentials that, again, you, your team, your peers, your colleagues, others that might have their information exposed out on the internet, where you can track down, even by domain, email, username, password, or even on the website that that data was leaked from. There is so much more you can do with Flare between their API, setting up custom notifications or alerts when some information is found out and about, or even just taking a look at generated threat intelligence and curated CTI pertinent to you and your business and your company. Maybe you need to stay on top of what information is out and about from threat actors and adversaries and what they're doing in the current landscape. Look, you can get access and see all this and more with a free trial linked below in the video description to get started with Flare. All right, now that we are inside of our virtual machine, we've got our fastmap.dll file downloaded and ready for us to take a look at. It's nothing fancy here, nothing special. Taking a look at the details, security information. It is not signed. There's no certificate that comes alongside this. We can start to open it up. Now, you might do this in IDA, you might do this in Ghidra, but we, in this video, can take it on in Binary Ninja. So we'll open that up. I'll click the open button, go navigate to it, and we'll walk through everything here, and it will start us in the _start function. You can see that in the very middle of the screen. We're taking a look at the display in the code view, where we actually can take a look at the raw bytes if we really wanted to, kind of much like a hex editor, but really we should get back to the portable executable, PD. Linear for how we might be able to view the code. You could, of course, see this in the graph view, which you might be used to in IDA or others. In the linear setup here, we actually could toggle this to the raw disassembly, where we're taking a look at just the assembly instructions, or the high, medium, or low-level intermediary language. Honestly, I really like the pseudo C code, because that way it just looks like code that we might be used to seeing in pure C. You do, of course, have all these symbols on the top left. We can explore those further, cross-references to whatever we're looking at, but really what we can start on is this start function here. All right, now before we go too far though, I do want to show you this really cool view that Binary Ninja offers you. You just go up to the view menu, they do have this triage summary that has a lot of really quick and convenient, easy analysis stuff that you might be liking in malware analysis, reverse engineering, usual incident response. You've got your entropy sort of visualization here, typical file info, header information, and we can scroll to the right there to see a little bit more. But especially with this being a DLL, it's probably worthwhile to take a look at imports and exports. Now, normally, like an online sandbox, maybe AnyRun or Joe's sandbox, hybrid analysis, whatever, they would try to kickstart and run for dynamic analysis with any exported ordinal, like run DLL, DLL.dll to call the file, and then like number 1, or the first exported function. Unfortunately, this has no exports. So pretty clear, this one's a little bit sketchy. This is certainly, and we'll find more, this is malware, but it's a little bit ghoulish on the inside, and I think that's worth noting. Look, see, kind of a sketchy, no exports DLL. Of course, we can take a look through the strings here. You can, of course, search through anything and everything if you wanted to within Binary Ninja, but there's nothing special or secret here. No easy wins. I can't just run strings and be done with it. We are going to have to do some real reverse engineering. So with that, let's get to it. Now, note this is a DLL, and that must mean that it's going to be maybe attached to or ran inside of a process or whatever loads that dynamic link library with a DLL reason as to whether it's being attached, detached, whatever. You're probably used to seeing that in the boilerplate code to create a DLL, and normally that arg2 would be the reason that is actually being worked with in this DLL. So we're checking if the arg is equal to 1, in which case we use this sub function call here, 1800C78, whatever. And if we actually double click into that, we can see a lot more of the usual boilerplate that's handling for like the security cookie, secondary stuff to handle that process. So nothing all that interesting for us. We can hit N on the keyboard to rename that as the usual security cookie function. Nothing fancy, hit accept, move on. We do have the call that follows though, DLL main dispatch. If I double click into that, it is, as you would expect now, to handle the reason with the DLL that was passed in with arg1, arg2, arg3. Now inside of this function, we want to track down where the code actually happens, like when things start, right? Because if we find some logic or a code branch that goes to the end of the program or the end of code to run, well, it's not going to run, and that's not all that interesting for us. So this conditional here, if arg2 is equal to 0 and whatever data value, we can double click in, noting that's just 0 to start, presumably. If that's less than or equal to arg2, then we return 0. Nothing happens there, so that's probably not interesting. We're probably not going to find the condition where arg2 is equal to 0. We might assume when the security cookie is set up, if arg2 is equal to 1, what we just saw before, we can see if arg2 less than 1, if we're subtracting 1 from it, is somehow suddenly then greater than 1, that would fall down this code. But that's probably not going to happen because we know maybe, presumably, arg2 is 1. So let's just kind of follow through with that train of thought here, thinking let's not take that if statement. If we were to do 1 minus 1 greater than 1, not going to happen. Let's hit the else statement down below. But if we do that, we set RBX to 1, which if we're checking if it's not equal to 0, which we know is now 1. So strange decompilation set up there, but that will actually tell us, okay, we call this conditional enter this rax tool equal our DL main CRT dispatch. R1, R2, R3 all being included. So we do follow through with this logic. DLL main CRT dispatch. Let's click into that and go see what that does. Oh, well, actually, taking a look at the code here, you can see a little bit more information on it either detaching, detaching, doing whatever it might do based off of R1 or R2 here. But that looks like regular handling for DLL. In this case, our R2 were to be 1 if we were, again, working with that hypothesis. We do end up calling this thing sub 1800C6F whatever. We can double click into that, and then what do? Scrolling through to understand a little bit more regular startup log, fast fail shenanigans, DLL main before initialized. That's going to end up initializing, having stuff run. This sub is just initialize slist head, nothing peculiar, default, local, standard input and output options. Oh, and then we do something with a lot of data values here. And we can double click into these, data 1800C8 whatever, more zeros as we expand and explore them. I'm hitting escape to go back, by the way. Same thing with another, nothing all that interesting, but we do check after initialize, we use this init term function with data again, currently being zeros, and then data again, currently being zeros. But in between those two, we do see a subroutine, a sub that is really something interesting. What is that init term actually kind of doing? Because that seems to be the only thing that will happen in this condition. Everything else is released. RDI check we'll go through with regular dispatch calls. Nothing fancy there. So that looks like the only thing that would happen if this is going to end up being returned out of the function here for our DLL CRT main dispatch, right? That function, if we go back into it, will do something with init term or init term. What is that? If we go Google init term underscore E from Microsoft documentations, thanks Microsoft Ignite, internal method that walks a table of function pointers and initialize them. The first pointer is the starting location in the table. Ooh, and the second pointer is the ending location. So it's just defining bounds when we saw that init term thing, whatever. And if it's going to initialize and probably run some functions, like realistically, that means that what we just saw at the start, C8200 being the zeros above, and then just following that was the C8210 being the end. That means that in between here, this data is a subroutine. Double click on it, that's a function. Oh, wait a second. It says, this function is too large to analyze? What was that? Yeah. Force analysis of this function. This may take a while. Okay, so giant bloated function, presumably. We can double click on that, and we can see down on the bottom left, analysis phase 1, it is now analyzing to rip apart and see that function. Might take a little bit, so I'll pause and wait until we get there. Okay, so now that this big sub 18000100 is done analyzing, we can scroll through it, and it's kind of weird. Like, you see all this? There's a lot of character variables being defined, a lot of 3s, randomly, like, weird random stuff, just a bunch of variables being created, a lot of 3s, a lot of 33s and hex, there just seem to be odd, and this goes on and on for a long time here. If I scroll down, this must be why that function was so big and was not analyzed automatically. But if I were like, I know I'm looking at the pseudo C, let me switch this to the disassembly and, oh, hey, Binary Ninja just took a second, it's hanging there, because it's probably taking so much time. A little bit of lag, I'll see when this comes back to life. Okay, yeah, coming back to us. But look, just everything you'd expect, move instructions, over and over and over again, adding to RSP and 1 new byte at a time. So execute this and put this all on the stack, ultimately, it's going to be loading something in the memory. So let me rename this. Let me just hit N to rename this to like MW. We can add that status. Yeah. Like whatever, maybe right payload is probably a fine name. But once that's renamed, let's sort of walk backwards and kind of, hey, remind ourselves how we got to where we are. I'll hit escape to bring us back, and I do want to bring this back to sudo C so we can see some of the code. Because remember, we saw that inside of that init term sort of function between those two bounds. And that was in this subroutine that was all inside of, we can call this whatever we wanted to, but it was in the DLL main CRT dispatch. And that DLL main CRT dispatch was in the else statement of DLL main dispatch that we started with. But once we were done with that, we could see we're testing if RAX2, the return value of that, if it did not fail, right? If it's not equal to 0, then we go to this label. So I double click on that. Oh, it just brings us back up to the else statement that we started with to begin with, but whatever. Ultimately, that calls this subroutine, which calls this subroutine if R2 is equal to 1. Let's drill down to that. Oh, and what's going on here? We can check while current process ID is not equal to hex 1234. That's not likely. That's probably not going to happen because that's going to be a random process ID. That will be a true condition, so we'll enter this while loop. We can check if we can flush file buffers, and that will be the break. So assuming that's not going to happen, we keep adding to RBX in the loop, and maybe some way, somehow we'll follow through. Once RBX is greater than or equal to whatever hex value, we do something with data. Data underscore 1800, and this is memory that we could click into and take a look. So it starts at 0. You can see that. And that's, I'm going to assume, an iterator, right? Because we have a do while loop here. But they do something interesting. They have an I null pointer where they're sort of doing like an inverse index into a buffer, presumably, because they keep growing and adding this over and over and over again. But that's a different data value, because the other one was ending in CA750. This ends in CA758. So double clicking on that, it starts as zeros, presumably. But this loop will XOR, you can see the clear as day, right? This line here, the caret symbol will XOR with hex 33, which is just what we saw when we got to see that other big subroutine function. And a lot of those 333 hex 33. So I'm curious, is that all the move instructions that we saw is just a second stage payload XOR'd with hex 33? We could probably take a look at that. We could extract that dynamically, but just to like go check, at the very, very top here, the symbols, we did rename that to whatever payload. If I double click in here and go see this one more time in the disassembly, take a look at these move instructions, right? We start with hex 7E and then 6-9. So let me open up like Firefox. This can be super simple, super dumb and easy. Like let's just get genuinely CyberChef open. And then literally 7E69, that is hex, right? So we need to do from hex. And then we can say XOR with the key being hex as the option set 33. The output is MZ, the very start of a portable executable header, or executable.exe or .dll, right? So that whole subroutine, everything that we're seeing here, is probably just another second stage payload XOR with hex 33. Let's extract that all out dynamically with a debugger. If I get back to the section we're in, when we saw this XOR option, we could just add a breakpoint after that do while loop. Honestly, we could just hit F2 and use the debugger here. Binary input. But I'll admit, I don't know. I've seen that do. I don't know how to set that up smartly with a DLL or dynamic link library. I do know that X64 debug, another debugger that so many people love, can handle that really nice and easily. It'll just use like